الو الو تمام. خلاص.
الو كده شغال؟ اه شغال تمام. اوكي اتفضل يا وليد.
تمام.
هو الصوت التاني عالي أوي كده ليه؟
بسم الله الرحمن الرحيم. Good morning everyone. Welcome to the imagery sessions track. I'm Walid Affat. I'm technical director at Esri. I have with me my colleague Ahmad Audi. He's principal consultant at Esri as well. So in today's track, on today's imagery track, we have 4 sessions. The first one is imagery in ArcGIS, which is like introductory session. Then we will have the second session will be a little bit intermediate. It will be imagery at scale. It's concerns about storing imagery in cloud. The third session will be reality mapping, how to convert the stereo imagery into, or even drone imagery into 3D and true orthos. And finally, we have the GeoAI session and AI in ArcGIS. So I move to my colleague Ahmad Awadi. He will start the presentation.
Thank you, Dr. Walid. صوت واضح؟ So as Dr. Walid said, the first session today is going to be about the imagery in ArcGIS. It's going to be an introductory session. So we're going to give a bit of information about the capabilities of imagery within the platform. And I'm going to take pauses between the different sections to open for questions if you guys have some questions. As a beginning to our session today, we would like to think and we would like to say that ArcGIS is a comprehensive, complete imagery system. Contains all the aspects that would enable and empower the users to deal with imagery, to analyze the imagery, to produce from the imagery, and so on and so forth. And that's what we're going to see in the next few slides. If we take a look back at the imagery platform that we have, we would like to divide it into 5 different pillars. If you look at the bottom, when you get an imagery, you have to manage that imagery, right? So we have a module and a software capabilities around the data management part. And then when you have that imagery part, you need to manage it. After you need to manage it, you need to optimize it, you need to serve it, and that's the data management. After that, you need to visualize it. And imagery have a lot of different data and formats and modalities. You're talking about multispectral imagery, you're talking about hyperspectral imagery, you're talking about SAR imagery. How do you visualize that? You're talking about stereo imagery. How does your software take those imagery data sets and types and allow you to visualize and see them? And that's the module or the pillar around the visualization. The third pillar will be around analysis. So once you've managed the data and you're able to visualize it and see it, you probably need to extract some information from that imagery. So you need to do classification, for example, change detection, or run an AI algorithm on the top of that so you can extract information from the imagery. And imagery, as we all know, is a gold mine, contains a lot of information. You just need the right tools and the right set of hardware to be able to extract the information from the imagery. And there is a lot of analysis that you can do on the imagery, and that's the third pillar. The fourth pillar is what we call the reality mapping, which is the ability to produce products out of the imagery, like, for example, digital elevation model, true orthos, or a 3D mesh and the point cloud out of that. And we're going to talk about this in much more details in the third session today. The last pillar that we have is the content pillar. Imagery is one of the data sources where a lot of people have challenges. How do we start with some basic imagery? Where do we get that imagery, right? So in Esri, we're a software company. We provide the software that enables you to run analysis on vector and raster as well. But we also have a data offering where we accumulated a lot of data sets, and imagery is one of them, to avail them to our users. And we're going to see that in much more details in the next few slides. So as a foundational on the imagery system, it's something that we've been working on for the last 13 years. We've been developing and increasing the capabilities that we have in the imagery until, as I said, we have the complete imagery platform and a comprehensive imagery platform. So if you look at the ArcGIS, it supports all the modalities and forms of imagery, and you name it, whether you're getting the data from any sensor, you have satellite, you have aerial, you have drones, or you have even some terrestrial camera. We support that imagery, and we support streaming that imagery into the platform. Also, the different types and modalities and forms of the imagery. So if you have scanned maps or multispectral or multidimensional or even video motion imagery or 360 cameras, those are all different modalities and data types that we support, and you can ingest those into the platform. We also support different, of course, the coordinate systems, the different ranges of formats that you can think of, different bands, different bit depths, different compressions, optimized, non-optimized, you name it. If anyone is working in the imagery and remote sensing, whatever you need in that in that piece, you're gonna find a component that will support you. So what are the different options that enables and allows you to use the technology? So from a deployment perspective, regardless of the technology that you're interested in or the deployment pattern that you're interested in, you will find an enablement component that will allow you to use imagery. If you're looking for desktop, for example, so there is the desktop component that enables you to work with the imagery. So ArcGIS Pro is there. Reality is there to extract information from the imagery and produce outputs. Drone to Map is there, and also there is an offering from Microsoft Planetary Computer to leverage their content and data. If you're an organization and you want to leverage enterprise, so there is an enterprise offering. There is ArcGIS Enterprise with Image Server that enables your enterprise and unlocks the imagery capabilities for that. If you're a customer and don't want to invest in the hardware and want to use the cloud SaaS model, so you just need a subscription to access the imagery and upload your imagery and work with that, there is a SaaS offering, which is ArcGIS Online for that. And lastly, if you're an organization, you want to leverage the cloud, but you don't want to use the public cloud, you want to use your own private cloud, there is a managed SaaS offering that enables you to serve your imagery and arrange the serving of that imagery in that offering. So the different deployment patterns are there. It's up to the preference of the end user to choose the patterns that they are interested in. Okay. Can you increase the volume? Just a quick overview from a software perspective. الصوت مش شغال. تديني المايك اللي عندك؟ شغال، الشباب مش سامعين. سامعين كده واضح؟ أنا معلي جدا. اللي هناك مش سامعين. وليد ما تجيب المايك اللي عندك؟ ألو؟ سامعين كده أحسن؟ تمام؟ البنات اللي هناك دي ناقيين. لا مش شغال. ها؟ كده أحسن؟ تمام. معلش. ما اعرفش هم مش سامعين. من هناك منين؟ واضح ان في conflict ما بين الاصوات ف they are reducing the volume. I'll try to speak louder. So now I'm talking about the products, very high level. We're not talking into details about the products. So on the desktop side, ArcGIS Pro is your friend. This is the tool that will allow you to unlock many capabilities, including imagery. And on the top of ArcGIS Pro, there is the Image Analyst, which is the extensions that allows you to deal with the imagery, manage the imagery, enables stereo, enables analysis, all the capabilities that you're looking for from an imagery perspective. If we look at the enterprise, which was the second deployment pattern, the enterprise comes with a capability called Image Server, which again is the piece of the software that unlocks the imagery capabilities on the enterprise level. Enables you to serve the imagery, enables you to run analysis on the imagery, and share those image services with your users. If we look at the online or the SaaS offering, there is an ArcGIS image capability on the top of ArcGIS Online that enables you to author the content, serve that content, and share the outputs. Of course, and then do analysis on that.
So either in ArcGIS Enterprise or ArcGIS Online, you can use ArcGIS Pro to author the imagery, to prepare the imagery. Then you can use our data information model about the imagery, which is called Mosaic dataset. You can create or author the image using coding, using Python APIs. And finally, you can use ArcGIS notebook, which leverage Python as well. Then in ArcGIS online, it's automatically created something we called hosted imagery service, which is imagery service that managed by the software itself, by ArcGIS online. Then we have other capability on the top of ArcGIS Online and ArcGIS Enterprise as well, which is called raster analytics. We can do the analytics on hosted image services and produce outputs.
Okay, تمام. And the last one is the image dedicated, which is something that we call ArcGIS image, something that you can stand up in your own private cloud, and you can manage massive amount of imagery there and serve it as well and run analysis on the top of that. This is something that is suitable for an organization that have massive amount of imagery, like a space agency, for example, and they want to serve that in an easy and efficient way. And it relies on different public, not public, I mean, yeah, public, they're private, but they're public, like Azure and AWS clouds in different regions where you can leverage the processing power that they have, so you can serve massive amount of imagery on that.
So some organization is already having its own data in cloud, either Azure, Google Cloud, AWS. So what we do in Imagery Dedicated is we put Imagery Dedicated software, which is basically ArcGIS Enterprise, next to the storage in the cloud, and we run it as Esri team, professional service team, we run it for the client. This is the Image Dedicated part.
Okay. Before moving, so the next section, we're going to talk about the 5 different pillars. I'm going to highlight each one of those pillars and what we have from an offering perspective, so to give you an idea. But I'm going to take a pause for questions. I'll take 2 questions if there's any. If there's none, I'm going to continue on. Any questions? Okay, that's fine. So the first pillar that we're going to talk about is the imagery content. That's the one that was on the lower left. And as I said, we're not a data company. However, we realize the importance of having some initial data to start from. And that's why we curated a lot of data sets from online. Some of them are free, some of them are commercial, and imagery is one of that. So for example, this is a glimpse of the different imagery layers and imagery content that we have within the Living Atlas. So as you can see, we have over 120 different layers that are imagery layers included. For example, a world imagery layer, which is a cached layer, which is a base map. There is the elevation layer, there is the terrain layer, there is Landsat layers that are there, which is a dynamic image or a tile cache. And that layer enables you to run analysis on the top of that. There is Sentinel layers there as well. So there is Sentinel-2, and there is Sentinel-1 for radar, and there is Sentinel-5 for environmental observation and atmospheric, and so on and so forth. So there are many layers and ready to be used as available as part of Living Atlas. I'm going to highlight some of the key layers that are widely used and mostly used by our users. So the world imagery is our flagship base map, and it's all the way from medium to very high resolution. In some areas, the resolution is few centimeters if we have some drone data. It's something that we aggregate from commercial providers, from our users, and then prepare it and produce it and share it with our users as well. This is something that we periodically update throughout the year. It varies from an area to another, so some areas get updated every 3 to 6 months. Some other areas might be every year. Some other areas might be every couple of years. And again, we're not a data company, so if you don't find an updated imagery within the extent that you're interested in, then probably the next step is to go to a data provider and get a fresh updated imagery on that. This is just an example of the world imagery, and as I said, it's something that we include within the platform, something that we highlight. Let me actually walk you through that journey and show you that live. so you can get an experience of what we have within the Living Atlas. As you can see, Living Atlas is a website, is a data portal. There are different tabs here. This is the landing page where you see the featured content and the highlights of the updates. If you go to the browse section, that's where you can find the different data sets categorized by themes, and the imagery is one of them. So if you go to the imagery, you'll find a lot of layers here. You can, of course, filter according to the content type. Right now on the imagery side, we have 156 different layers that you can take advantage of and leverage. The Living Atlas is available across the platform, so you can access it from anywhere. If you have ArcGIS Pro, you can access the Living Atlas within the software. If you're using the web, you can also access the Living Atlas. And accessing Living Atlas is as easy as just opening a layer that I'm interested in. I'm looking for the world imagery. I'm just gonna open that layer and just drag it to the map, and it's ready to be used. So of course, all the metadata about the layer, all the details, the different imagery contributing to that, and the attribution and the metadata about that. All what I need to do is just add that layer to the map, and I have a high resolution world imagery base map that I can rely on. I can go anywhere in the world, so if I use the search here, and since we are in Riyadh, let's go to Riyadh. And that's Riyadh in front of our eyes. I'm gonna zoom in just to see the highest resolution piece of imagery that is here. So you can see it's a very high resolution imagery. I think the resolution here, if we click on the image, is 30 centimeters, and the last update was February 2024. So that's something that you can take advantage of and leverage. There are other tons of available stuff that you can leverage within Living Atlas. For example, we accumulate all those different base maps that we have world imagery, and also avail them to our users. So the previous drops of base map, we still keep them. And we have an application to expose that. It's part of Living Atlas as well. If you go to Living Atlas here, there is a section about the data. That's the second section. And the third section is called apps. And we have different set of applications that leverage the Living Atlas data and exposes them to the users. One of those apps is something called Wayback. By the way, these apps are open source. So you can download the source code and the template of that application and use it with your own data if you want. They are perfectly designed from cartography perspective, from a GIS app perspective, so you can take advantage and use these applications. Let's look at the world imagery Wayback. Again, as I said, sorry, I cannot see the control here. Yeah, so if I go to any area here, let's go again to Riyadh. As we saw earlier, the last drop for Riyadh was February, probably 2024. It's gonna refresh. And on the left side, I can see all the different, it was published in August, but it was acquired in February 2024. I can see all the previous imagery drops, and I can even load them if I want. So for example, if one of the base map drops colors and corrections were not up to my standards, or for some reason I want to go back in time and get 2 years older for comparison, or use it for change detection or whatever, I can do that. I can just swipe back and see all the different historical images that I have here. So that's something that we advise you and encourage you to take advantage of and leverage.
One of the best practices, we use those different base maps. I mean, the Wayback base maps is to run a deep learning model for footprint detection, and we get like the footprint building footprints that, for 2024, for example, and get another one for 2020, and do some kind of vector detection, change detection.
This is my favorite part as a functionality on the top of the application. You can actually do this kind of change over the time, over the series of images that you have, and you can even download it as an MP4 video. So let's assume that you have your own imagery, you have historical imagery. You can use this application template to visualize your imagery. You can also show the change that is happening, and you can even download that for your user. It's a very nice piece of functionality, and it's very useful. Let's say that you're monitoring a construction development area, and you want to see the progress that happened over the time. So that's a very quick, easy way to do that from a visual perspective. The third thing that I'm going to show on the Living Atlas is one of the applications that leverage the Sentinel service and the different capabilities on the top of that. And in this, I'm going to do a bit of a combo, so I'm going to show different pieces. So in this example that I'm showing here, I'm looking at a Sentinel imagery that was captured in July 2023. That's in an area where they get a lot of rain. They get a rain season. So as you can see here, the optical imagery is not helping me. I cannot see something here. Probably I need to go to, oh sorry, actually that was the visible one. I can see there is a lake here. But if I go to August, that's the rain season, I cannot see anything. Because as you can see, the clouds are covering everything. And that's when SAR data comes in handy. That's when SAR, because the radar can penetrate the cloud, and even in a cloudy season like this, I can still see through the clouds, and I can still see what's happening on the ground. SAR is a bit of a sophisticated data, so now I'm picking, I mean, it's not 2023, but it's still the same rain season. And this is the same area of interest or extent that I was looking at earlier. And just looking through the SAR imagery, now I'm able to see through the clouds and see whatever happening in the ground. In this case, I'm monitoring this lake and I'm monitoring this water accumulation happening behind the dam. So this is another capability that is possible.
Actually, this application has 3 components. One is the Sentinel-1 imagery or even Sentinel-2 imagery, which is stored in AWS bucket. So we put ArcGIS Enterprise next to this bucket, publish the image service, and use this JavaScript app. It's open sourced, it's available for you. So if you have other image services, you can plug and play, you can use this application.
Thank you. I mean, we have tons of content to show on the Living Atlas, but I'm going to leave it to you to explore. So Living Atlas is a website, is your friend. Go and use it, explore the different imagery that is available there. You'll see tons of data. I mean, for example, NASA, they publish what they call Earth data that they produce on Living Atlas in ArcGIS Online. So all the different layers that NASA is producing is available on Living Atlas is something that you can take advantage of and just drag and drop and start from there. Living Atlas, as I said, it's not only for the imagery, it also has a lot of content, a lot of data that is there. So aside from the imagery, there is also a lot of other content. Some of it actually is continuously updated. Like for example, the earthquakes data is a data set that is getting updated every 15 minutes with collaboration with USGS. So you just need to drag that layer and start working with that. The weather station from NOAA is another layer that is getting updated every 1 hour, and you can rely on that across the whole globe. So it's not only limited to imagery, but because we're talking about the imagery, it's something that we talk a lot about that. This is the other layer I'm going to show, and then I'm going to switch back to the presentation just to give you a sense of what you can do with Living Atlas. This is the wind and weather data set. Again, another layer that I can just drag and drop. And if you see here, the coverage is global. So you're going to see a lot of weather stations around the globe, anywhere. And as I said, it's frequently updated. So it's updated every hour. If we click on a station here, probably the timing is 9 a.m. Yeah, so it was updated about 50 minutes ago. So this is something that is continuously updating. You can take advantage of and leverage. So that's in a nutshell when we talk about the content and a bit of introduction on Living Atlas. We talked about the highlights, we talked about the world imagery. One announcement that we have here is coming up very soon. The Skywatch content is going to be available within ArcGIS Online and Living Atlas. So you can actually purchase commercial imagery directly from within the ArcGIS Online and Living Atlas. It's work in progress. It's very exciting for us because Skywatch is one of the biggest imagery aggregator out in the market, and having that seamlessly part of the platform, or at least they're offering as part of the platform, it will make it easier for you. So you look for the imagery in Living Atlas. If it's not there, or you want to task or request a fresh imagery, you can do that immediately from within the same platform. So that's something that we're very excited about. Again, the flagship layers that we have there, Landsat, this layer contains about 40 years plus of coverage. So you can go back all the way to the 80s and the 70s, and it's an analytical layer. So since it's a multispectral layer, then you can probably analyze that. It's a layer that we update every 4 to 10 days. So it's always getting a fresh update, so something that we encourage you to use. Sentinel-1, as I just demonstrated, that is one of the recently added layers. Gives you a lot of possibilities. The archive that we have is from 2014 to the present days, and the revisits are every 6 to 12 days. Any questions? That's when I'm finished that part, and I'm going to talk about the next part. Do you guys have any questions before we move to the next section? Okay, very clear. So the next pillar is the management pillar, which is a very critical and important piece to the platform. Imagery is unlike the vector. For example, the vector you can in a personal geodatabase or a database, you can put the whole world shape files or polygons and major cities and everything, and the size of that file will not be exceeding 20 megabytes. A vector is a very compressed, and it's different than the raster. With the imagery, the story is different. You're talking about massive size of imagery, size of files that is there, and the possibility or the capability to manage those imagery is a bit challenging. We're talking about gigabytes, terabytes, petabytes of data. How do you organize that imagery in a way that will enable the people to access it without feeling the performance issues, the bottlenecks? That's why the imagery is a bit more challenging than a regular vector data to serve it and to architect the back end and to serve it efficiently. The management of the imagery starts with the way that you access the imagery. So within our ArcGIS platform, we have it all. So you want to access it directly, drag and drop the file on your desktop, you can access the imagery. You want to have a connection to the cloud to access, which is, as Dr. Walid said, is something that is very common nowadays. We're seeing initiatives from Microsoft and Amazon. There is a planetary computer that have hundreds of terabytes of data that is available, or even petabytes of data that is available to be used. Amazon also have their Earth observation program where they also store massive amount of imagery that is there. So having a connection to the cloud is one way to access that massive content and leverage that, which is the ACS, or the cloud service connection to enable the secure access with credentials. The second way of accessing the imagery is to serve that imagery to the users, which is a very common thing that the people are used to, which is caching the imagery. Back in the day, it was a bit challenging to access live services from the imagery, or what we call the dynamic imagery. So the best way to serve the imagery was by caching it. So pre-processing the imagery on different zoom levels, generating those pre-cooked tiles, and then when the customer requests them, it's immediately transferred to them. Way better than back in the day. The server would go and cut and extend and then pass it back to the client. That would take a lot of time. So this is the tile cache. It's there, it's supported, and it's even optimized. So when you create a base map imagery, we compress the files. So back in the day when you used to generate those pre-cooked tiles, it would generate millions of those small caches or files. So transferring them from a place to another was a big challenge. Now it's a compressed format, so it's a single file or multiple few files that you can move over from a place to another. Updating the cache was a challenge. So let's say that you received an update to a certain area, but you don't want to update the whole base map. So there are tools that allows you to specify certain extent and update or rebuild the cache for that specific extent. The third type, which is a mix, is something that we call tiled imagery. So what's the difference between the tiled cache and the tiled imagery? Tiled imagery is the same concept as the cache, but enables you to run analysis. With the cache, you cannot run analysis. You're just transferring some small caches to the end customer for backdrop or base map display, but it's not analytical. If it's a multispectral imagery, you cannot do anything with it. You're just having it for backdrop. Tile imagery is using best of both worlds. So it enables you to stream a pre-tiled imagery and also allows you to serve that even if it's a multispectral. Previously with the cache, multispectral imagery was not an option. But with the tiled imagery, you can stream that multispectral imagery optimized so it's fast, and also you can do client-side processing. So you can publish some raster functions alongside with your service, so you can enable your end user to run, for example, NDVI on that imagery. So it's getting best of both worlds. There are some limits to the tiled image, and that's why we go to the dynamic imagery. Dynamic imagery is, as I said, historically used to be slow because of the processing power of the back-end servers. But it's the way of doing the processing, the extraction of the data from the imagery using the server capabilities. So it's server-side dynamic mosaicing and on-the-fly processing, and also the analysis as well on the top of that. It has improved amazingly over the years. I'm going to show an example of Landsat dataset, which is a dynamic type of imagery that you can analyze and you can work with, and you will see the performance, how it's behaving on that. The other types of imagery access that we have, and it's not limited to that, is feature attachments. I can attach an image to a vector feature, for example. So that's another form of enabling the imagery access within the platform. And the last one is something that we call I3S. This is specific to the 3D. This is our format, which is an open source, by the way, that enables you to stream 3D content, whether it's a 3D mesh or point cloud, in a very optimized and very efficient way. Now, we're going to see that later when I'm showing the reality demos. It's one of the best formats in the market to do the 3D tiles streaming, very efficient, very fast, and it's very optimized. So these are the different ways of accessing the imagery.
Actually, I need to highlight, the difference between, it's very important, between the tile cache and the tiled imagery. Tile cache, the same like Google. When we serve tile cache, we cannot preserve the pixel values, and we only serve 3 bands, the RGB. So we cannot perform any analytics on tile cache. In the contrary, tiled imagery, we serve the real pixel values with all the bands, so we can perform analytics on the tiled imagery.
Thank you, Dr. Walid. This is just an image to visualize the difference between the tiled and the dynamic imagery. You want to speak over?
For example, here for the tiled imagery, it's client-based analytics. So there is no server-side processing. The pixel tiles will be streamed to the client. I will ask for those 4 pixels. Then I get the real value of the 4 pixels. Then I can do the client raster function within my machine, in my machine, so there is no server processing at all. But of course, it needs like a good bandwidth, network bandwidth, because I'm streaming a real value of the pixels. For the dynamic imagery, no, I just request an extent. Then in the server, there is a processing for the whole extent, doing the analytics like NDVI or whatever. They're returning back to me only the result. So the advantage of having dynamic imagery, I don't need like a high bandwidth of the network. Maybe I can use a low bandwidth, but I need like a good server configuration.
Thank you, Dr. Walid. So that was from the imagery access perspective. The next part is going to be from what else we have in our pocket for the imagery management. If you have different formats, we support them. So different data types, different forms or modalities of the imagery, different, video and radar and LiDAR. We support all these formats and modalities. If you're talking about from a sensor perspective, we also support a lot of the sensors that are out there, and we keep updating that. So for example, Landsat is supported, Maxar sensors are supported. Even the local in the region area sensors are supported, like there is Khalifa Sat or Dubai Sat. If you go within the sensor information, you will see the support pieces that are available there. So it will recognize, if you're receiving a data from Khalifa Sat, for example, it will recognize the folder structure and it will recognize the metadata that comes with the data as well. So it would make it easy for you to start your own data management journey. If you're talking from a data model perspective, and that's the heart and core of the management for the imagery, we have different data models that enables you to deal with different data types. If we're talking about imagery, of course, the king of that is the Mosaic dataset. And in the next slide, we're going to talk a little bit about it. If you're talking about LiDAR dataset, there's a LiDAR data model that manages that LiDAR in an efficient way. If you're talking about tile cache, there's a specific format that manages that in a very optimized and compressed way. If you're talking about multi-dimensional data set, there's a multi-dimensional CRF type of data model that manages that data. If you're talking about the mesh, so there are different optimized data models to your data to serve you. So that will enable you to serve those different sensor type of data in a specific data model, so you can share that efficiently and securely as well. Because identity is a big part of the platform. So once you manage the imagery and share it, you specify who are the users that are gonna use that. And sharing itself, there are different ways of sharing the imagery. You can share it as tiles, you can share it as dynamic imagery, as we just talked about it. You can share it as catalog layers or voxel layers. Those are different other types where you can serve and share imagery as well, oriented imagery or 360 as well, while keeping in mind the identity. So in the next slide, what is the Mosaic dataset? What do you want to take over this one?
So simply, the Mosaic dataset is just a container. It doesn't store the imagery, just reference to the imagery. And the good thing about Mosaic dataset is I can attach a business logic to it. I mean, attach raster function. I'm loading all the Landsat data and attach like a function to do the NDVI or the water index. So once I publish the image service with the whole Landsat data, the raster function will be applied automatically. So once I publish the image, I got the NDVI directly. So from the Mosaic dataset, I can produce a tile cache package. It's again the tile cache thing. Then I can produce something we call cloud raster format, which is CRF. It's invented by Esri. It's like very optimized way to store the multi-dimensional data. I have two types of it: the CRF for the optical image or for the imagery itself, which I might store like one band image like digital elevation model, then Landsat imagery, multispectral, then maybe spot imagery. And I can convert it to just one file, which is cloud raster format, multi-dimensional one. Then I can use the Mosaic dataset to be a multi-dimensional data store for the multi-dimensional data, like for example NetCDF data. And I can manipulate the NetCDF or the multidimensional data. I can manipulate the multidimensional CRF. I can transpose it and do analytics of it. I can serve it again to be a tiled imagery. And finally, I can publish the Mosaic dataset and apply image server raster function, raster analytics, to run it as a distributed processing. Then I can produce another output. It's called raster analytics service. It's like CRF data as well, but served in the portal. And by the way, we have like a full workflow management for the different types of data to be converted or to be managed by Mosaic dataset for example, high resolution imagery, for
scanned maps,
imagery, for scanned maps, for drone maps, for aerial photos. We have this ready in place. We call it Mosaic dataset configuration script. It's Python scripts or Python tools available on our website, can be downloaded and can be run via ArcGIS Pro.
Thank you, Dr. Walid. So from a data model, we were highlighting that. I mean, Mosaic data set is much more advanced, that it can be grasped in few minutes. But it's very powerful, it's very optimized, that enables you to manage your imagery, serve it, apply a lot of processes on the top of that in a very efficient way. Have you guys heard about the stack? How many have heard about the stack or used the stack before? Okay, okay. So stack is the spatiotemporal asset catalogs, which is a way of organizing the imagery through the catalogs. It's, I think the standard came from NASA. How do I expose the catalog of my imagery in a very easy and efficient way without the need to explore all the archive of imagery, all the petabytes of data? So that's where the stack is. It's basically just like think of it as an XML and a catalog of the items that are available within the archive. It doesn't contain the data, but it contains information about the data, so you can actually quickly fetch the information about the catalog, and then it contains reference to where the data is, and we do support that stack. There are many of the like Planetary Computer and Amazon Earth Observation Program. They expose the massive amount of data that they have as a stack. And there is a lot of other organizations as well that started adopting stack to expose this their massive amount of imagery to the rest of the world. So stack is supported. You can immediately within ArcGIS Pro connect to a stack and also create a Mosaic data set from a stack. So that's a very easy and efficient way to leverage those massive content that is available on the cloud. That's from...
All the imagery right now available in Azure or in AWS, like Modis, like Landsat, like Sentinel-2, Sentinel-5, are available with the stack metadata. So it's preferable to connect to the stack catalog, browse the data, and get it to your machine, or even upload it to a Mosaic dataset.
Thank you, Dr. Wali. What other imagery data management and capabilities that we have from a management model? We do support something that is called trajectory data set. So for example, if you're collecting satellite altimetry data, this is something that is used to observe the sea level rise and the ice cap melting and all these things. It's something that point data that is being captured across the orbit of the satellite, and then you can take that data and use it for analysis. Very specialized data set used with certain satellite providers, ICESat-6 and some other satellites as well. Oriented imagery, which is the 360 type of imagery, there is a data model to manage that. So if you have, if you've captured the streets using one of those cameras or even a GoPro camera, and you want to take that data and manage it and link it to the GIS, that's where your imagery, oriented imagery data set comes in handy. LiDAR data set is another data model that is important. Catalog data set, which is a type of generic data set that we have that can harvest the data and ingest any type of data type within it. So within the catalog data set, you just connect to certain folders, to certain databases, or certain extent, and it starts, or folders even, starts exploring the data that is in there, show it as sub-layers under the catalog layer, so you will have vector, you will have imagery, you will have whatever is available within that extent, or whatever, or within the data that you're searching is available through the catalog data set. It's an easy way to crawl through the data and explore it and organize it in an easy way. The other capabilities that we have is something that we call video server, which is taking those video that we call it full motion video capabilities and share that into the enterprise. So it's something that you can stream and share with your people. Oriented imagery, as I spoke about it earlier, it's just the ability of taking those 360 imagery and linking them to the map. So I can have, same as the street view that you see in Google Maps, it's the same capability but within your own data. Let's take a look, a quick demo or a quick view of what the video server would look like. So once I created the imagery, of course the imagery has, the video has certain specs where it's going to be geotagged. I can link that video layer with the map. And I can view it. This is Excalibur, one of the applications that we have in the web. And this is ArcGIS Pro. I can add the same layer. The video server capability, this capability used to be in ArcGIS Pro for years, for over 10 years. But the new thing is ability to publish those video layers to the enterprise, so I can share it with my users, I can share it with the rest of the world. So this is the highlight of the new video server that we have. The same video layer here, I'm loading. This is a capture by drone, so it contains the information about the location as well, and I can see the current exact point moving on the map while I'm viewing the video. So this was from a data management perspective. I know that we're running a bit short on time, so I'm going to try to wrap up the rest quickly. The third capability is about reality mapping. We have a dedicated session for that, but I'm going to just highlight reality mapping is the process of creating accurate digital representation of what we see in the physical world using the LiDAR and the imagery. Reality mapping, in a nutshell, it's a product or an engine that takes your imagery that was captured by drone or aerial or satellite and then produce these amazing outputs that you see from here. It can produce true ortho, it can produce surface model, DSM and DEM, it can produce point cloud and 3D mesh out of that. So that was in a nutshell. Let me just show you what's the output of a reality engine looks like, or reality capability. The 3D scene that you're seeing here is one of the examples of the outputs that you can produce from the reality engine. As you can see, it's a photorealistic mesh. And then on the top of that, you can add additional functionalities. So you can integrate a real-time data, for example, and use it for your own use case. We're going to talk a lot more about the reality because we have a dedicated session for that. The fourth pillar is about the analysis. And the analysis is a big aspect of imagery. I mean, imagery is used as a backdrop, amazing base map, but visual inspection is good, but it doesn't scale up. How do I find the changes that happen with the scale of Saudi Arabia, for example? I can see it visually, but I'm not gonna zoom in into every corner of the imagery to find the changes. So I need to have a tool that I'll give it an older imagery, a newer imagery, and then it will tell me where are the changes from vegetation, what are the changes from urbanization, what's the growth like, and so on and so forth. So this is the capability that we have. Tons of imagery analysis tools are available. They're exposed within the desktop. They're exposed within the web. So you can have those available raster functions and capabilities that you can leverage within on the top of your imagery. And added to that as well, the AI have been on the geospatial data for a few years now. So you can use AI algorithms and model, and of course the imagery is amazing. The computer vision is one of the most progressive AI algorithms that is out there. So you can leverage that. So you have tons of capabilities from an AI perspective on the imagery. Whether you want to do classification, whether you want to do object detection, whether you want to use it on 3D data, whether you want to use it on video motion data, all these pieces is something that you can leverage an AI algorithm to give you an advantage of that. We have an afternoon session with my colleague Ahmed Nuruddin. He's going to talk a lot more in details about the AI and the different pieces there. But I'm just going to highlight some of the improvements that we've added in the AI in the last few months. From an AI perspective, you have to start from a model. And we have trained many models, and that's something that we keep increasing over the time. So the ones in yellow are the ones that we added recently and we improved. So these are the new models that we added to our pre-trained GeoAI models. So for example, the text SAM, which is the model that you just give it a prompt and tell it to find planes in the picture, and it will extract for you automatically. The Prithvi model is something that was done between IBM and NASA, where they trained over 100 billion, where they trained the model over on over 100 billion images. So the model is very well trained to detect phenomena like crops, like the burn scars from the fires, like the flood, and so on and so forth. So that's another new addition that we added there. Let's see them in action because we've added so much capabilities. So I'm gonna highlight them in the next 2-3 slides. This is an additional capability that we added when you're doing the AI workflow about the training. So you know one of the steps in the AI is to train the model. So you give it samples of what you're looking for. And in this example specifically, we have an AI text prompt assist AI label assistant. So in this picture, instead of digitizing every plane to use it as a training data set for my AI model, I can just type quickly, as you saw here, I can just type planes, and then immediately it will start fetching all the planes that are in the scene. And then of course I can export them and use them to train my model. I can do the same with other phenomena as well. Like I can use the same AI assisted label assistant to extract trees, for example, and then extract them and use them for my training. Or buildings, for example. In the next example, it will be creating the labels for buildings. So I can type, okay, get me the buildings or the rooftops. So it's gonna automatically assist me. If you guys have done AI before, you know that the labeling is a time-consuming task where you have to go and digitize over the feature that you're interested in, one by one. So having any help there can save you, because you might be digitizing few thousands of label, and that takes a lot of time. The next improvement that I want to show is is improving the training of the deep learning model. We have a wizard for that, and also what we call O2DL. You're going to hear more about it in the afternoon. So O2DL is, you want to use AI, you don't know which model to use or which backbone to use. So you can actually run this automatic deep learning that will examine your training data, examine the imagery that you have, run different models and algorithms and backbones on the top of that, and give you AI assessment report. As you can see here, the model have tested all these, the AutoDL have tested all these models, gave me the information about that, and that is presented in a report.
It's a very important point here, because one of our challenges as GeoAI analysts, which model will detect an object, for example. We have a lot of models. We have like YOLO 8, YOLO 9, detection. So which model, according to my data, will give the best result? So the AutoDL functionality tests all of these models and produce this kind of accuracy confusion matrix for me to decide which model should I use.
Okay, thank you, Dr. Walid. The last highlight of GeoAI, and again, you're going to see more of it, is something that we've been working internally. This is going to release soon. It's something that we call segment anything with spatial prompt. It's basically using your spatial prompt. So you say, whether you put a point or you type it in a text, it will extract the object for you. So in this case, I'm just putting a small points within the picture, and the tool will extract the objects that is enclosed within that if it's a car. So this is what's happening here. The next one, which is very exciting, this is coming probably in a week time, it's an interrogation of the features in the imagery. This is amazing, because you can actually ask the tool to tell you from a plain text. You can tell it, describe what is in that imagery. So this is the input that I'm providing here. So now we're leveraging large language model and asking it to describe what's in that image, and then the output or return is the interrogation of that image. So it's going to tell me this image shows an aerial view of a large outdoor of an amphitheater, which is situated in a desert-like area. Amazing, right? You can give it an imagery, tell it what's in that imagery. Another example here is like, okay, what is this object and what color is it? So it's going to interrogate that imagery. It's going to find the different objects that are their objects. So it's going to exclude other things, and it's going to actually interpret the colors of that. Amazing functionality. This is not yet, it's going to be released very soon. So stay tuned for this improvement. If we talk about other analytical capabilities, I'm going to move very fast because we're about 5 minutes to the end of the session. So SAR capabilities is something that we have in the analysis pipeline. It's something that you can use and leverage. So check it out. I just showed a quick example. Scaling the imagery analytics is something that we have within the platform. So this is just an example. Imagery is now supported on Kubernetes. So it can scale up and scale down. And Enterprise is Kubernetes enabled. Imagery is a component of that, so it can leverage Kubernetes. So you can scale up and down your analytics. And we're talking about, this is an example from the US, where we had to analyze 3.8 trillion pixels. Imagine the amount of processing that you would have to go through. This would take months on a regular server machine.
How many of you know about Kubernetes? Kubernetes simply is, we can call it like the operating system of the cloud. So in the cloud, we will not use like Windows or Linux. We will use Kubernetes for the sake of scaling the machine. So ArcGIS Enterprise right now is compatible with Kubernetes, can be deployed in Kubernetes, and also the image server can be deployed in Kubernetes as well, which means that I can scale the image server for doing more analytics in a very quick manner.
Yeah, thank you, Dr. Walid. So as you can see here, I'm scaling up and scaling down, reducing the time that I needed to do the analysis initially from 6 hours all the way to 58 minutes. This is a very hot topic, and Imagery is really leveraging the Kubernetes technology to scale up and down, and the analysis, because it's intensive and takes a lot of time, is something that is very important. I'm going to show a last demo on the analysis part before moving to the very last piece of the visualization, which is Hyperspectral. Hyperspectral capability is has been added to the ArcGIS Pro in the recent release. And this is something that you can use and take advantage of. I'm going to show it as a video. So here we're looking at Jake Dingermont Preserve, where we have a lot of trees and species and everything. And multispectral is an excellent data set to show the variations between crops, between different phenomena that I'm interested in. Here I'm connected to the data set from AVIRIS, which is an airborne visible infrared imaging spectrometer. I'm adding the data. I think this image contains about 425 bands. Imagine, I mean, what we were doing with this multispectral 8 bands, imagine the possibilities with 400 different bands that you can do. So the adding of that data is here. The data strip is gonna be added to the image. So that's what the aerial imagery captured. As you can see here, there are many bands, so you can actually, we're expecting a boom in the in the spectral type of analysis with the multispectral. Hyperspectral. Thank you, Dr. Walid. Here, I'm just managing the hyperspectral data, adding it to Mosaic data set, and then clipping that to the area of interest. In this example, I'm going to examine the spectral profile using the tool out of the box. You can see the spectrum profile of the different points that I'm clicking on. And then here, I have extracted, like from visible observation, different oak trees, and then I'm going to use the tool to analyze that. So I want to detect the same parts of the imagery that contains the same spectral wave signature that are similar to those that I picked by hand. So I can run that analysis to extract the oaks. So I had I have identified visually some oak trees. I have pointed those points so I can get the spectral signature that matches those oak trees, and then using that spectral signature that I have, I can run this on the whole imagery to extract the similar oak trees signature from the rest of the image. So I can have this this output, and you can see here the green area represents where there is a possibility of matching the spectral signature of the same oak trees that I had. The last section, and I'm going to open for questions, is the visualization. So the ability to visualize all these amazing things that we saw, stereo, 360, video, and this is the pillar that talks to that. How can I take a video capability and then show it within a web viewer or show it within the desktop? How do I have a stereo pair imagery and be able to use the glasses and do the digitizing on the top of that? So this capability speaks to that, that allows me to use different imagery so I can visualize that. Multi-dimensional data set, how can I visualize and see that? And because of the time, and I want to give 1 or 2 minutes for questions. So I hope we quickly covered the imagery from an introductory standpoint, talked about the different pillars. Each one of those, by the way, can be another session by itself, because there are components, there are how do you tune the things, how do you understand more about this, but this is just a high level glimpse of what's possible within the Imagery platform. And as you can see, we have so many capabilities and possibilities depending on your use case, depending on your interest area. Thank you so much for attending. I hope it was useful for you. I'm going to open for questions. If you guys have any questions, please raise your hands so we can take the questions. Sure.
Assalamu alaikum. Many thanks for this useful many thanks for this useful information. Very useful صراحة on the high level. But I need to ask, how can connect to Google Earth Engine or compatible ArcGIS engine with ArcGIS Pro to link it with many sources data?
Okay, we don't connect. Google Earth Engine is like an analytic engine that connects to Sentinel, to Landsat, to Modis to do the analytics via programming interface, via JavaScript. We do the same. So we connect to the open satellite data like Landsat, like Sentinel, the same way, but the addition that we are providing is you can connect to your own data as well. Google Earth Engine connect to the public data. Google Earth Engine is an analytic engine. Our product, our image server is data management program and also analytics engines. We don't connect to, it can be connected, we cannot connect to the Google Earth Engine. At the end of the day, it's like analytical engine. We connect the same data, do the same analytics with an interface.
Yeah, I know, but you know your ArcGIS engine have many resources, many.
Sorry, ArcGIS عربي.
ArcGIS engine فيه كتير من الداتا
ArcGIS ولا جوجل؟
جوجل. في كتير من الداتا والريسورسز اللي احنا ممكن نستفيد بيها.
ما هي موجودة، هي كل الداتا اللي موجودة على جوجل انجن موجودة فري، فهي اكسسبل اوريدي. الحاجة اللي انا بضيفها زيادة اكسسبل في جوجل انجن بايه؟ بجافا سكريبت، يعني هتكتب كود. لكن احنا عندنا ذا سيم داتا واكتر كمان من غير ما تكتب كود، وكمان انت ممكن يور اون داتا. يعني احنا عندنا وزاره الزراعه هنا مثلا عندها درون داتا، دي ما ينفعش اشتغل بيها بجوجل انجن، ما ينفعش اشتغل بيها لانها في الاخر برايفت داتا، صح. فانا هشتغل بيها بالسيستم عندنا.
شكرا.
Any other questions? اتفضل.
Okay. My question is that ArcGIS reality related. Does it support the multi-ray imageries? Does it support multi-ray imagery? Like if I have the mobile mapping data, at the same time I have the aerial drone data by another sensor, oblique sensors, and integrating all these three different directions imagery, three different multi-ray imageries. Can we generate the 3D models using reality?
Right now, from a reality perspective, it doesn't support like a mobile mapping system integrating that into the reality output. But it supports when you're talking about specific sensors. If you're talking about aerial, for example, there are aerial sensors that we call them multi-head cameras. So the camera itself contains 5 different cameras, oblique and nadir and everything. There are also drones that have multiple cameras installed on them, so they can actually capture oblique and they capture nadir as well to give you the different views and the different shots that are required to produce the reality output. But integrating LiDAR or integrating MMS into the output and then fusing them all together, it's not in the reality. Okay.
And does Imagery provide any solution for interior mapping of the infrastructure?
Of course, yeah. I mean, there is when it depends on the scanning that you're doing. If you're scanning it by LiDAR, for example, you can capture that LiDAR data set and produce an indoor out of that. There is another specific solution around the indoor mapping and indoor capability. So that's another realm outside of the imagery. But you can take the output of that and then produce indoor mapping out of whatever you scan.
And, can we utilize this reality for close range photogrammetry?
Yes, something like what is it called, near field NRF. We have some experimentation. I can show you that if you attended the reality session. I can show you.
Yeah, I will attend that.
Okay, I'll show you an example of the close proximity that was used, I think, in archaeological documentation website.
Yes, thank you.
Thank you. There is one more question. Two questions. Okay. Sorry. Yeah.
First of all, I would like to ask Dr. Walid and Engineer Ahmed for the informative presentation.
Thank you so much.
I'm wondering, out of the box, you don't have, or there is no any orientation to have a video analysis? Because now we are showing, but I would like to have a change detection of videos, because I'm working in urban violation for a national, and we have every 1 month a video for the area. If there is no any idea how we can do a video detection that change in the facade of the buildings.
We do have some AI algorithms on the video for detecting. We have a couple of algorithms on the video analytics from an AI. One of them is detecting the objects from the video. So it basically cuts the video into shots, or into frames, and then detecting different objects. We've tried it, for example, on detecting the cracks on the road, captured by a 4K high definition video camera, and then inputting that, and then identifying the locations of that. From a change perspective, I would guess you would have, the core is there. You'd have to adjust that a little bit to do the change. There is another algorithm.
We have the model, Doctor. We have the model in ArcGIS Living Atlas, so we can utilize it in ArcGIS Pro directly.
Thank you so much. There's one more question here. Sorry. Two more questions.
Thank you for your information. My question is about how can we get the advantage of this technology in making prediction for animal, controlling animal diseases, in source of predicting the risk areas, the best area for grazing, especially in the area we have areas, we have the sort of nomadic and semi-nomadic movement of animals.
This is not like in the imagery kind of thing. We have another model. It's called suitability mapping. So it's simply you provide the layers that affecting how you detect or how you delineate the grazing areas, and you can use this with weights, with like. For example, for the grazing area, I need like a certain type of vegetation. So I put it as a single layer with a certain weight. Then the weather, for example, and so on. And apply the suitability model, it will detect an areas for grazing, like even closed area, vector area. We have it. So we can discuss it offline. We have a model for this.
Okay, one last question. I have actually two questions related to the marine benthic habitat map. Can we do water column correction and atmospheric correction for the imagery using
atmosphere? Yeah, of course. We have. If you check the ArcGIS Pro, we have a certain tools in the raster function gallery for radiometric correction.
Okay, and what about the water column correction for the depth, for the bathymetry in the marine aspect?
We have this, but you can customize. We have other raster function available on our Living Atlas as well, doing this, but it's not in ArcGIS Pro, but you can import it in ArcGIS Pro.
Okay, all right. Thank you. Shukran.
Thank you. The next session will be for imagery as well, but mainly handling the imagery and the data formats. Shukran. Thank you.
It was really useful. I have another question.
Oh yeah,
track that we have. In this session, we're going to talk a little bit more in details about the different options that you have with the imagery management, about the different deployment options, about a bit more about the analysis from a deployment perspective. So we're talking basically about just a high level on the system design and architecture for the imagery. So it's gonna be a little bit technical, not too exciting demos in that session, but hopefully it will be interesting for you from imagery management perspective. My name is Ahmed Awadi, and I have with me Dr. Walid Affat, and we're both working for Esri, focusing on the imagery and AI and a lot of other aspects as well. So the agenda for today, can you guys hear us in the back or no? Is the sound clear? Okay. Increase? Well, I'm trying, but they keep reducing it. Yeah. Yeah. أرفع شوية معلش. طيب كده أحسن الحين. أحسن؟ أوضح؟ تمام. Okay. So the agenda that we have for today, we're going to have an overview of the imagery management modes and the different options that we have there. We're going to talk about the imagery system deployments, and we're going to give sample architecture of how to properly deploy the imagery. We're going to talk about the image server, the raster analytics. We're going to talk about the stack, ArcPy and Python API. Not too technical, but we're going to highlight what is possible there, and we're going to open up for questions. So stay tuned with us throughout the session. So if we start from an imagery management overview and modes, if you attended the previous session, this is fresh in your mind, right? We have 5 pillars. The bottom one was the data management, right? And this is what we're going to talk a little bit more in details about. Do you recall from the previous session what was the data management about? Managing the massive amount of imagery that is out there and putting that in a data model so it can help and serve, because the imagery is the cornerstone. So you have a content, you have your raw imagery on the left side, whether it's local on your machine or in the cloud. You ingest that data to a module where you can manage that imagery, so you can organize it to make it accessible, and then you can serve it after that as web services or image services to expose it to the rest to the rest of the world, and you can expose it via different ways. So you remember we talked about cached, dynamic. So there are different ways and modes of serving that, and this center core part, once the management is done properly, then you can visualize it. Then you can do analysis on it, and then you can produce outputs or use Reality Suite on the top of that. Sorry for the overlap, but this is a bit of needed introduction for the people that didn't attend the previous session. And as we saw previously, from a management perspective, support all the modalities, support all the forms of imagery. So different types of imagery, multispectral, hyperspectral, different sensors, aerial, drone, satellite, terrestrial, different formats, different bands, different bit depths, all these pieces are supported. And also from a data management perspective, the sensor information is supported. There is a lot of optimized data models, and that you can efficiently stream and share within the platform. Coming to the new slides. So what are the different imagery modes that we have? How can we serve or save the imagery, share the imagery with the people? So let's split it in mind. There are 2 ways of serving the imagery, or what we call them image management mode. There is something that is called hosted, and there is another thing that is called curator. In a nutshell, what is the difference between them? One approach is to share the imagery by value. So copying the whole imagery to the server, and then sharing the services and the available capabilities from the server. This is what we call hosted option, system managed. The other option, which is actually increasingly more interesting, because I'm not going to move terabytes and petabytes from data from right to left. It's not that easy. It takes a lot of time. Which is the curator managed. which what we call by value type of that. So the imagery is located somewhere, shared storage, NAS, or local storage, or a cloud storage, or anywhere, and it's stored there. So I have my server here, I'm gonna just point to that storage, and then serve the imagery from there. The benefit of that is, of course, I'm not duplicating the data, I'm not taking a lot of egress, moving the stuff right and left. Wait, do you want to talk?
Yes. So we have two use cases. The first use case is the hosted one. So imagine I am a GIS analyst, I'm an imagery analyst that is having 1 or 2 images on my machine, on my desktop, and I want to publish it to either ArcGIS Enterprise or ArcGIS Online to share the imagery with other departments. So what I should do, just click on the imagery, click share, put my credential for ArcGIS Online or ArcGIS Enterprise, and boom, it's there. I don't know anything about the imagery, what happened to the imagery. It is all managed by the system. The imagery are copied to ArcGIS Online or ArcGIS Enterprise servers, and that's it. So I am not managing the imagery in the servers there. So it's a very simple approach, very straightforward approach, but it has limitation because at the end of the day, I need to copy all the imagery to the server, to the image server. But in the curator manager, imagine that I have like a hard disk, like 2 tera hard disk, full of massive amount of imagery, and I want to serve those. So publishing them into ArcGIS Online or ArcGIS Enterprise as hosted, it will cost me a lot of bandwidth. It will have a lot of time to be there. It will cost me like storage in the server itself, the image server. So instead, we will just reference the imagery and saying to the ArcGIS Enterprise, hey there, you have this hard disk in cloud or even in NAS storage that is having 4 terabytes of imagery, publish them. So the server will just point to them and publish this something called imagery definition, image service definition only. This managed by you, because at the end of the day, you're having your own disk, you have to manage the formats for the 4 terabytes of imagery in your own disk, so you are responsible for everything. But the key point here, by value, meaning copying the image to the ArcGIS image server, here by reference, meaning you will not copy anything, but you will manage your own image. Okay?
Thank you, Dr. Walid. To summarize what Dr. Walid said, put it in a nutshell. So this is a schematic or a diagram of the workflow for the hosted imagery. So you have the source on the far left, and then within ArcGIS Online or Enterprise or Pro, you create a new item or a new layer, and that moves that imagery into the hosted raster store or hosted image services and creates an item out of it. The typical user for that, as Dr. Walid said, is the analyst, someone that has few images on his machine, and he wanna quickly get the possibilities. he doesn't have, for example, ArcGIS Pro. He wanna use the web to analyze those imagery and maybe share them later. So that's a typical user case. It's available within ArcGIS Online. It's available within ArcGIS Enterprise. The process is basically just going within your online or enterprise and click on new item, and then new imagery layer. Within ArcGIS Pro, you can do the same process, but from something that we call create hosted imagery layer. So it will, the two options that we talked about can be initiated from enterprise or online or from ArcGIS Pro.
Simply, simply, how do you usually, guys here, you have ArcGIS Pro, how you can usually publish your image in ArcGIS Online? Just click to the image, create hosted image layer, you have your credential for ArcGIS Online, and that's it, from ArcGIS Pro. But there is another way. Just open ArcGIS Online, add item on the portal called the imagery layer and pointing out to your image, and that's it. It will be copied to ArcGIS Online server and published there. So you have two ways. If you have ArcGIS Pro, which is our traditional way to publish the imagery, and if we have ArcGIS Online. But if we have ArcGIS Enterprise there, and we don't want to use ArcGIS Pro, so the same experience as ArcGIS Online. I open my portal in ArcGIS Enterprise, create a new item, and add the imagery. But this will entail that we will copy, the imagery will be copied to the ArcGIS Online server. We call it raster store in ArcGIS Online server or in ArcGIS Enterprise. It will be hosted layer. What I mean by hosted, that Esri will manage it. You will not do anything about it. Imagery copied and the imagery converted to image services in the hosted raster store. You don't know anything about this hosted raster store. You shouldn't be worried about administrating the raster store. Okay? This is the hosted imagery workflow. At the end of the day, you will get item layer on your portal that can be used in desktop or in web or on mobile, or even you can create dashboard using this image server.
I was going to show it live here. So this is exactly what it looks like. You come here in the new item that I clicked, and then you click on the imagery layer, and that will give you the various options of creating the new imagery layer. There are different options, and we're going to talk about them. There is dynamic and imagery. Probably you guys have captured this from the previous session. I'll put the slide. And then there is also the different modes of adding the imagery. So
what Ahmed did right here is he opened ArcGIS Online, he added a new item, he select the image layer item and upload the image, and that's it.
The first question that I was asked here is tiled versus dynamic, right? What's the type of imagery that I want to create? If you attended the previous session, now you know the difference between the tiled and the dynamic imagery. But we're going to repeat it very quickly. Cached, I mean, you can see that I wrote cached here, but cached is no longer the case. It's a tiled imagery where pixels are streamed to the customer. It's already pre-processed before for the different scale levels or extents that I'm generating. It enables you to stream multispectral imagery. It enables you to run analysis on the client, and it's optimized for streaming. It consumes a bit of bandwidth, but it's very optimized for streaming. The dynamic imagery is once a customer or an end customer requests a certain extent, the server will go and extract the exact extent for it, and it will pass it back. So it's a server-side processing. All the raster functions are available and possible. All the processes of mosaicing and ortho rectification is also available. It's a single request. The output is small. Here, the output is also small, but relatively bigger, because these are pre-cooked tiles. So whenever the area of interest intersects with those tiles, you will see that those tiles might be slightly bigger than the area of interest that the customer or the user is interested in. That being said, the server processing time to extract that piece compensates for whatever borders, and that's why the tiled imagery is the fastest way of serving imagery, bottom line, as of now.
Yeah, so I'm not sure, do you know guys the idea of having cached the image? What is the good thing about having cached the image? Cache the image meaning I will not direct the processing to the server to do things. It's like pre-cooked tiles of imagery, and I just point to those tiles and retrieve it in my browser. The same as Google. I'm sure that you have this experience before. First time you go to Google Earth or Google Map and display the imagery of maybe Al Ula or Riyadh, and display it on your browser. The next day, when you view the same image, it will be much faster, because the system, the Google Earth already clip the tiles, load the tiles, and put it in your machine. So it's very fast. So right now, you're accessing only your machine, not the server of Google. So the same here, but the problem, the same for our ArcGIS platform. The same, we cook the cache and provided the cache to you as a user, so it will be very fast. But the problem of cache is you cannot analyze the cache because it has limited number of bands, 3 bands only. So if I'm going to do this kind of spectral analysis to, for example, extract vegetation from the imagery, I cannot do this with cache. But Esri has done, like, take it further. We created a cache, but with information. I mean, here is the tiles. The client will ask for like 4 tiles. The advantage of these 4 tiles, it will be transferred to the client with the real information. The 4 bands, the real pixel value of each tile. So the client here with his machine can perform all type of image analysis. It's great because right now I'm not depending on the server. I am not depending on the network bandwidth. I'm depending on the power of my machine only. And it's very good. However, sometimes I have a low bandwidth. What I mean by low, internet speed is having like a limitation for me. For the first option here, I need a high speed internet. I need a high bandwidth because the pixel values here and the bands transferred through the network. So I need to have a good bandwidth for the network. But here, no. I just ask for request for those 4 pixels, and what transferred to the server here, just the coordinates of the extent. And the server will do the analytics, transferring back the result of the analytics only, not the pixel values, just the result of the analytics. So all the processing will do in the server. So the dynamic imagery mode doing everything inside the server, using the ArcGIS image server. Here, I'm using your machine to do the analytics. So this is the big difference between the tiled imagery and the dynamic imagery. Which is better, depending on your case. For example, you have a low bandwidth, you have like a limitation on your internet speed. So you have to go to this option. And the good thing, this option having all the available functions or remote sensing function in the market. However, in the tiled imagery, we have like 80% of the whole function because we have limitation, because at the end of the day, you're doing it with your machine. So again, it depends on you and your use case, either to use dynamic imagery or use tiled imagery.
Thank you, Dr. Walid. So on the next screen, when we have this option or wizard, we can pick the type of imagery that we want to create. You will see there are multiple options here to create that. So let's explain them in details. So what are the hosted imagery options? There is an option that is called one image, and another one that is called one mosaicked image, and a third one called multiple image layers. What are those and what is the difference? So,
okay. So again, the first 3 options is for tiled imagery, and we all now know the tiled imagery idea. But for the first case, I have just one image, and I need to publish one image, and that's it. It's very simple. I need one image, publish, became one image service, tiled image service, and that's it. But the second option is I have like 3 images. I need to like publish them, share them as one image service, as one image. This is the second case. The third one, I having like 3 image layers, and I need to publish them as 3 separate image services. So I have the options for the tiled image.
Yep.
Those tiled image services. Okay, so in the third option, like third multiple image layer, I created 3
different layers.
Tiled image service corresponding to each one of those images.
Yep.
Okay? So what about dynamic? Those 4 options. The first three are the same. I mean, for one image, I can
وليد
publish
المايك.
or create one dynamic image service. The second one, 3 images, I mosaic them and created on the fly, and created one image service, dynamic image service, one dynamic image service.
وليد المايك معلش قربه
Sorry?
شوية. المايك قربه.
Okay. The third option, the same as here, at the above one. I have 3 images, publish them at 3 different dynamic image service. But the fourth one is a great one actually. I have 3 images. I can, once I'm publishing the image as dynamic image service, I can use option called image collection, which means I will publish or create one dynamic image service, just one. But I have the access for those 3 imagery. It will not become like one, like the soul. No, it's just separate, but just representing on the server as one dynamic image. So those are the different publishing approaches.
Thank you, Dr. Walid. So this is from a hosted imagery, from the hosted mode. That was the left side. The right side is the curator mode. So the first side is clear. Now I'm an analyst, I want to upload few imagery. There is a wizard for me, I'm going to upload those imagery, and I serve them depending on my preference for single layer, multiple layers, or one mosaicked image. So I decide that dynamic it's not static, tiled. Yeah, thank you. So that's on the left side. The second approach is the curator managed, which, as I said, is increasingly getting more traction and more focus.
Again, Ahmed, can
Sure.
This is a key differentiator, guys. I mean, storage is managed by administrator or asset manager by reference. We have NASA storage, we have a cloud storage that having 4 or 5 terabytes of data, and I need to publish them to create tiled image service or dynamic image service. So I'm responsible for the storage here. This is the curator managed option. However, the hosted, I'm not responsible for anything. I already copied all my imagery to the server.
So the workflow or the diagram of the curator is like this. I have a source imagery. I am a curator. I'm an image asset management manager that I manage that massive amount of imagery. I have to create a data management part that manages this imagery, which we introduced in the previous session, mosaic data set. And from that mosaic data set, I can start publishing the services on the top of that and share them as items or layers. Serve them to desktop, web, mobile, or even put them in a dashboard. So the process is the process is create the mosaic data set inside ArcGIS Pro, and then point or reference or give a pointer to that imagery within the mosaic data set, and then publish that as non-hosted by reference, as we talked in the beginning, to the enterprise, so I can share it with the rest of the world. There is also an option that is called Create Hosted Imagery Layer within ArcGIS Online that enables me to create from the mosaic data set the layers and the items within that. So that's just in a very high level what is a curator managed workflow look like.
Did you notice, guys, here, I mean, there is no option that I can create new item in ArcGIS Pro or ArcGIS Enterprise to create a creator managed imagery? Because the source here, again, the source here is NASA storage or a disk that having a massive amount of imagery data. There is no option to use ArcGIS Online or ArcGIS Enterprise to author the data, to create an image layer. The only option is using ArcGIS Pro. So if you are going to take the creator managed approach, that you have a massive amount of imagery that stored in a disk, you should go to this workflow of creating a mosaic data set inside ArcGIS Pro reference the mosaic, the MD here, the mosaic data set to the images in the disk that you are having, then create a non-hosted image service. What I mean by non-hosted, that we
By
didn't
reference.
copy the images. Images is still there in the hard disk. This is the big difference. At the end of the day, it will be created as an item layer in the portal, in the ArcGIS Online portal, or even ArcGIS Enterprise portal, and I can use it in desktop again, or web, or mobile, or dashboard. Okay?
Thank you, Dr. Walid. So the next part, as a curator, as we talked about this mode, is how do I optimize that imagery? Again, the imagery is massive amount of data. We're talking about petabytes of data. And using those raw imagery and then serving them, it will come at a great cost from a performance, from streaming that imagery. So there is an essential step that I need to do before serving that imagery. So I need to optimize that imagery. I need to convert it. And of course, with the rise of the cloud computing, as we saw, Microsoft Planetary Computer and Amazon Earth Observation Program, they host a lot of imagery. So that imagery needs to be stored in a very optimized way, something that we call cloud optimized formats, something that is native to the cloud, something that allows multiple reads, multiple writes in case of running analysis on the top of that. And there are two ways of doing this from the previous schematic that we showed earlier. So I have the source imagery on the left-hand side. I can run optimize rasters on that. So instead of getting that imagery that comes as GeoTIFFs or MRSID or any of those, the GP2 or any of the known formats, I need to optimize that. So I can produce one of the very optimized cloud formats. And we're going to talk about the cloud optimized formats in the next slide to tell you the difference. Esri, we have a great cloud optimized format that is amazing. We're going to talk a little bit of details in the next slide. So once I produce this cloud optimized, now I'm ready to create my mosaic dataset. Now I'm ready to put the imagery within that, and it's optimized. So it's compressed, it can stream efficiently, and it can be accessed from multiple clients and read and write in a very efficient way. The other approach is, if I don't want to go with this path, if I don't want to convert my raw imagery, my original imagery, to the optimized format, I can do it later after creating the mosaic imagery, after creating the mosaic dataset. So I can still connect to the source, raw imagery, and then create the mosaic dataset on the top of that. And then after that, after I do the creation of mosaic dataset, I can create an optimized imagery from there. I can use the copy raster tool, so I can convert from the mosaic, not from the source raw imagery, from the mosaic that was generated. I can create an optimized cloud format, and that's the one that I'm going to use for serving. So that's two approaches of optimizing this content.
Okay, so question for you. What formats that you are dealing with when doing this kind of analytics on the imagery? What formats you usually do?
You guys are familiar? What is the typical imagery format that you're currently using with imagery, if you're dealing with imagery at all? TIFF, thank you.
GeoTIFF.
GeoTIFF.
Exactly. GeoTIFF. GeoTIFF is the most proper format to dealing with the image. But it is not a cloud optimized format. What I mean by cloud optimized format, if you store GeoTIFF in your hard disk and try to access them with your browser as services. So I send a request. I having like a GeoTIFF image for the whole Riyadh. And I need to add only to display or to do analytics in Al-Ula. So I will request the server, I'll send to the server the extent of Al-Ula to the GeoTIFF image. What happened? The algorithm or the structure of the GeoTIFF entails or like doing the following. Will copy the whole images to me. All the pixels of the image, all the extent of Riyadh into my machine to be able to analyze. This is not cloud
optimized at all, yeah.
The meaning of cloud optimized is just I can draw a rectangle or whatever the area of extent, send it to the server, and the server will only respond to me with the only pixels that impounded within this box. This is a crucial difference. No one from the big names that's storing imagery like AWS or Azure or Google storing the imagery as GeoTIFFs. So what the formats that can be cloud friendly? The first one of them is
put the
COGS,
slide, Walid.
cloud optimized GeoTIFF.
Walid,
COGS.
it's on the screen now.
Yeah. COGS. Cloud optimized GeoTIFF. COGS. The meaning, the purpose of having COGS, because COGS has the ability, I send an extent and it will respond back only with the pixels like embodied in this extent only. But the problem, I'll explain this later, but let's focus on this table. So the problem of the GeoTIFF or the COGS or the cloud optimized GeoTIFF, which is COGS, we don't have local cache. I'll explain the meaning of local cache right now. The most disadvantage thing of having COGS, there is no parallel write. So if I have multiple servers and I need to expedite the process of doing the analytics and store the output in multiple servers, it can't be like doing the analytics over COGS images. So it has limitation. Also, every time I request a pixels from COGS stored in the server, it's getting back the same pixels every time, like new request. There is no caching. There is no pre-cooked cache in my machine. This will not be happening while using COGS. So what Esri did, she adopted another format. It's called meta raster format, MRF. It's better than COGS because it has parallel read and it supports local caching on server. What I mean, but it supports local caching server. If I access the server and get the pixel is stored forever in my server, like 2 or 3 or 4 weeks. So whenever I need the pixels, I can find it on my server. So it will be very fast. It doesn't need every time I should go to the server and get it back with the pixels. So, but it doesn't have, it has the same problem. It doesn't have no parallel write. It has the parallel read. What do I mean by parallel read? If I store my images in multiple hard disks and I need to access all of the multiple data as one shot. So using meta raster for MRF can do that, can read on something like parallel manner. But what is the most preferable format for us to do this kind of cloud analysis? It's cloud raster format. We invented this extension, this file structure, new file structure. It's called cloud raster format. It supports parallel read and write. So I can parallelly read files and parallelly write the result of my analysis in my data store. So the good thing, if you are using ArcGIS Online, having image server on a service on ArcGIS Online, and you did analytics, like calculating NDVI in Riyadh, and you apply raster analytics and produce a new image. The newly produced image stored as CRF in our portal. So we already pushed on you to practice the best, to do the best practices of having CRF as output of your data. So what our recommendation is always before publishing the data is to do kind of optimization to your image data, either by using a function or a geoprocessing tool called optimize raster. It allows you to convert GeoTIFFs into either COGS or MRF or CRF. Or I can use
Copy raster.
something called copy raster, and copy raster works with mosaic dataset. So imagine that you have this scenario, you have geotabs in your server, on your hard disk, and you already create a mosaic dataset from those imagery, and you need to export the whole mosaic dataset for the whole Riyadh as one file, CRF file. You can use something called copy raster here. And you can also choose which compression mode that you want to use. Maybe you can use, for example, LZW, LURC, whatever. So it's available. All the compression modes, it's available for you. What's recommended is LURC. So this is the whole idea about optimizing the imagery. And it's very important because sometimes customers come to us saying, I mean, the performance in the web is very, or our web application is very slow. So I will ask, I usually ask them, guys, did you optimize your imagery? What formats did you save the imagery or reference the mosaic dataset to which image formats? They said maybe COGS, maybe sometimes UTF even. So I said, no, just do, the first thing you should do is to have an optimization process to your data. That's why our recommendation in Esri, if you are like imagery centered organization, like for example, GeoAI, GDMS, whatever, there is like someone called system administrator, like IT system administrator. What we are right now, we are suggesting to have someone called the imagery system administrator. He's focused only on imagery, because right now imagery is getting massive day by day. So we need someone to optimize those imagery, suggest to the customer which workflows that we should use, which number of bands that should be used. Maybe I can optimize the imagery by reducing the number of bands, by the way. So yeah, so this kind of optimization is very crucial. Using either optimize raster or even copy raster to get the output, and then publish using mosaic dataset, using the CRF format.
Thank you, Walid. I know that we talked a lot about the optimizing, but it's a crucial piece of the imagery. Imagery is a massive data set. We're talking about terabytes, petabytes of data, and there are limits to the processing power that I have. How do I scale up? And the aspects that Walid talked about is very crucial. The multi-read, multi-write is essential for analysis, because there are limits, as I said, to expanding the hardware, right? But I can do distributed computing, for example. Distributed computing would not be possible if I don't have multi-read, multi-write, because a single server would lock the file, would not be able to produce the output, and that's done. So I'm not leveraging the distributed computing. So those aspects are very crucial. The compression is very important. Instead of transferring that massive amount of imagery, compressing that while preserving the quality to the acceptable level is something that is highly recommended. So all these practices are really, really important. Keep them in mind, because these are the cornerstones of doing that. And that will lead to the next slide, when we're talking about why are we doing this to serve the imagery, whether I'm curator or hosting or hosted type of persona, to do the analysis. So this is summarizing the whole workflow. So I have the source imagery. If I'm in the curator mode, I probably optimized my raster. These are not like the paths that you have to go through. These are alternative options. So I can maybe optimize the rasters and have a cloud optimized format. Or maybe not. Maybe I'm just going to go immediately into ArcGIS Pro and create my mosaic data set and persist that using the copy raster tool. That's another path in the curator mode. Or maybe I'm working in the hosted mode. So I can be probably creating the new layer item in the enterprise or the online, or maybe use the create hosted layer inside ArcGIS Pro, so my layer will be served and hosted immediately. If I choose the curator managed path, then I start generating products out of this from the mosaic data set, and then I can serve that imagery Again, as we said, it's a non-hosted, so it's by reference. I'm not copying the whole imagery, and then create an item out of it. Once I have the item here, now I can do analysis. So I have item that is coming from the hosted option, and another one that is coming from a curator managed option. Both layers or both served imagery can be streamed to the customer, so I can consume them, and also the customer can use those item layers to run analysis. So I mean that the diagram is a bit flipped, but once I reach the item layer here, I can start running raster analytics on the top of that. What is the output of the raster analytics? It's another item in the portal. And the output, in this case, is going to be a hosted layer by default, because it produces the output and produces the physical, the layer that is generated as a hosted layer. So this is just summarizing the whole workflow, picking different options.
I need just to add like a simple information. This is like a basic information. You see raster analytics here. If you are doing analytics in intranet or internet, you cannot do it on imagery. You should do it on image service. So this is the basic idea. That's why the raster analytics here, which is responsible for doing this kind of parallel processing thing, it will use the item layer from above or the bottom one. Item layer, which means, item layer meaning that it's item for image service. So the input for raster analytics in the web or internet is image service. So we have to publish our imagery for sharing the analytics and the visualization. Okay? This is like a basic foundation for the whole like discussion we are saying right now.
Thank you, Dr. Walid. So this is the deepest technical part that we talk about. The next stuff should be lighter. Hopefully you guys didn't get bored. Stay tuned. The next session is very exciting. A lot of demos, a lot of interesting looking stuff. So wait for the next session, but we're gonna wrap up this one in 10 minutes. So what are the deployment options? We talked about it in the morning. So we have desktop, we have enterprise, we have SaaS, we have managed SaaS. And all the different modes that we talked about can be served through the options that are available on the screen. If we talked about the different options, what are the capabilities? So from an enterprise perspective, there is a capability called image server that unlocks the imagery capabilities. So you can share the imagery as hosted by reference image services, and you can also run analysis on the top of that, and you can scale that up.
The question here, why I'm using ArcGIS image server? It's a very basic question again. The ArcGIS image server is the software piece that enables me to share my physical image.
Yep.
Period.
Second option or the other option is the SaaS, which is, again, if you guys paid attention, SaaS would be hosted only. So SaaS will not give me, it will manage the imagery for me, it will allow me to create the new item, and that's it. I'm not gonna be able to create curator managed option within the SaaS ArcGIS Online. Clear? Just to put the dots on the line for the different options. We'll talk a little bit about the enterprise and image server and raster analytics from an architectural standpoint and capability. So image server, as we said, is an extension or a capability on the top of image server, yeah, is a capability on the top of an enterprise. This diagram shows you the constellation of capabilities that you will get from the image server. So as you can see, the foundational part to serve and disseminate imagery data with all the supported imagery formats, as you can see in the diagram. The image service also supports the map cache, so you can improve the performance and the display performance of that. Other, let's call them signature capabilities, includes the support for OGC, for example. You have an OGC service, WMTS or WMS or any of those things can be infused and ingested into the enterprise and the image server and served through the enterprise. So the standards open endpoints are supported, and it supports the on-fly processing, the on-the-fly mosaicing of the data and data visualization. Beyond sharing the data, image server also can be used for with the analytical engine that is included with it. and it provides over 200 different built-in raster functions that enables you to create workflows, so you can enable analysis quickly on your data. We have two types of analysis that can be executed. There are things that can run on the fly, and these run immediately, so it will happen in no time. And there is another one where I need to run for every single pixel on my whole imagery. That takes a bit of time, and that's the option where we can leverage something like the distributed computing, and also making sure that our imagery files are in the right format to support that. For the imagery content and the imagery that is served that we see in this diagram, it's all REST enabled. So it can actually integrate with other systems, infused into other systems. I can open it from even our own platform products, ArcGIS Pro, or the web applications, or the mobile applications, but it also can be exposed to the other customers like another system, and they want to see the backdrop of the imagery. That's something that is available there. So it will enable these different use cases. So I can empower mobile applications with imagery services. I can empower web maps with image services. I can put them in a developer application and get that imagery layer and then build my amazing application on the top of that. I can search and discover the imagery catalog that I have. I can use it in my mapping production systems, because it's a very critical part for any mapping production system that they would have the imagery as a backdrop, so they can digitize or do stereo or whatever they're going to do there. So this is just in a nutshell, the image server and the image server capabilities on the top of that. Let me show you. I know that we have about 6 minutes.
So yeah. I will not go into the details of this. It's a little bit like architecture, diagram. So the most important thing when you install the ArcGIS image server, you need to have like 2 separate servers. This is the message from this diagram. One for analytics, and it can be replicated if you want to speed up the analytics, and one for visualization, if you want to speed up the visualization. And that's it. And of course, you need to store your data, either in file share or cloud storage, and create mosaic data set from those data. So you have two options storing the data. Either in file share, we call it NAS, so you can store imagery, you can store mosaic data set, and so on. Or you have something in cloud, like AWS or Azure, or even your private cloud, we call it blob storage. It's not file share storage or file system storage. It's called blob storage. And you create mosaic data sim, this is a plus sign. You can use this or this, but you need to create a mosaic data set from those data inside either the file share or the blob storage. That's it. If you are like in your organization interested in doing analytics and you want to speed up the analytics, so I need to create like a suitability map using Landsat imagery for the whole kingdom within 2 hours. I need to like spin off or replicate the raster analytics server like 3 times to do this kind of parallel processing. If I need to be very fast when it comes to displaying the imagery, I can replicate the image hosting server. Both of those server, we will install the ArcGIS image server. We will not do anything in addition installation, I mean. And that's it. So
yeah, that's a very good example. I want you to take a screenshot and keep it in your mind, because imagery deployments are a bit sophisticated. It's not like a single deployment machine, shove all the software on it and pray that the imagery will be fast. It's not going to happen. Fact of life is there is optimization for the data, but it's also architecting your infrastructure. That's a critical piece. What we've done here and what Dr. Walid explained is we did something that we call workload separation. So instead of shoving the imagery and the regular map services on the same server and they get loads, the imagery is a massive pipeline of data streaming happening to the customer. So I do that kind of separation so I can actually control them. I can actually increase the instances of the processes allocated to that service, to that server, instead of affecting the whole system. So that's a very important concept, multi-deployment machine, and it's very important to design when I'm having when I want to serve imagery or run analysis on my system. I need to design my system taking into consideration all the aspects. Is my imagery going to be in the cloud? How am I going to do the storage? And then separating those pieces to make it work efficiently, work properly, and be served right. And to show you that there are options within the enterprise, that enables you to scale up and down the instances allocated.
Maybe it's a little advanced a little bit, but the system administrator will be aware of this. So for the first, the left part is the image hosting part, which is responsible for image visualization. So this is my image service that I published using ArcGIS Enterprise and ArcGIS Image Server. It's called New York SRTM 30 meters. This is a service based on the STRM data. So suppose I need to speed up the visualization time. So what the administrator need to do is to go to the ArcGIS server manager and increase something called maximum instance. It's a little bit complex, but again, the system administrator will be able to do it. It's very straightforward. But if you want to speed up the analytics, you will go for this service. It's like a standard service in our system. It's called raster processing service. You can increase the maximum instance as well, meaning increasing maximum instance, increasing the cores or the instance or the processing units that deal with imagery. And that's it.
Thank you, Dr. Walid. I know that we're about 2 minutes to that. I'm going to show a demo and the last slide. This is the last slide because we mentioned the API. Whatever you've seen previously can be automated. So using Python API, using Python G processing, you can automate the process of creating the layers. In the previous session, we talked about Mosaic dataset configuration scripts. So I can automate the creation of Mosaic dataset in an automatic way. If I have like constant updates of data drops happening, how do I update my Mosaic datasets without dedicating a person doing that manually? I'm going to show a demo, and in this demo will speak to a lot of the points that we talked about. Remember in the previous session, we talked about the Living Atlas, and one of the layers that was hosted there is Landsat. Imagery layer, 30-meter, multispectral from USGS, been roaming the Earth since the 70s, and serving massive amount of imagery. This is what happens when you have proper architecture done for your server. By the way, the machines empowering what the services that you guys are seeing here are only 5 virtual machines. That's it. And the single drop of Landsat, because Landsat gets updated every 5 to 7 days. A single data drop is somewhere between 140 to 170 terabytes for the whole globe. So how is this application or that imagery service is able to retrieve those imagery in an acceptable, very fast manner compared to the volume and the sheer volume of that. So all the practices were taken into consideration. The file format, the proper architecture that needed for that, so you can actually stream the imagery in a very efficient way. Not only that, the Mosaic dataset archive, actually, let me zoom to an extent or an area that I'm interested in. Let's go to Riyadh. It contains the historical data as well, so I can go back in time and pull older imagery almost instantly from the same archive. Imagine those petabytes, not terabytes now, because we keep accumulating. Imagine those petabytes of data, and I can go back in time. Let's pray that there is a scene here that I can pull. I'm just trying to load it. Yeah, see? How many seconds will it take? And that data doesn't reside on my machine. It's in an Amazon cloud in the US West probably, and it's served there. But
so this is example is curated managed imagery. We have a bucket, we have a folder in AWS that's storing all the Landsat imagery starting from 1974 till today. So I installed the ArcGIS Enterprise and ArcGIS Image Server next to this bucket. This is the folder in cloud, and publish an image service that containing all the Landsat imagery that keeps updated. The image service keeps updated every day. Why I'm able to do that? Because I have a proper design. I separated the visualization and the analytics. I put a good configuration for the machines. I already designed a proper architecture for the images. I did the optimized processing on the image before storing it in the S3 bucket in AWS.
And as you can see here, I can serve analytics as well. That's the 200 functions plus that we talked about. On the top of that service, I can run analysis, so I can answer questions quickly. I can ask like, what is the NDVI index? What is the agriculture index? Or even do some analysis if I want to do spectral profile or change detection and so on and so forth. I'm very conscious of time, so I think we stole 2 minutes of your time, but we started late. Do you guys have any questions? Thank you for attending.
Thank you for your time.
I hope it was not too boring for you. But the next one we're going to have is about reality. It's going to be very exciting. A lot of interesting demos. We would like to hear from you guys. If you have any questions, please speak up and we can pass the mic to you. Any questions for the content that we showed for this session? That's fine. Ah, you have one question, sure. Thank you. Mish.
For image storage on a local machine, like a network drive, you recommend SAN or NAS?
Probably the preferred one is, I mean, SAN is faster, but NAS is more cost effective. If you can store it on SAN and you have the budget, definitely go for it. It's much faster. But NAS is very common, and the performance, there are different types of NAS that comes with very acceptable performance, and they serve very well shared storage, and that is good. So I think the key factor here is the criticality of your performance and the budget that you have.
Thank you.
Thank you. Thank you so much. Thank you everyone for attending. It was nice having you. Let's see you in 10 minutes, inshallah. Thank you. لا لا قشطة. Assalamu alaikum everyone. So we're gonna be having a session, the last session is going to be on reality. Yeah. So we're gonna be talking about the reality. If you attended the two sessions that we talked about, one of the components of our imagery platform was the reality mapping. And in this session, we're going to talk a little bit more in details about the reality mapping. So the agenda for today is we're going to have a bit of introduction about the reality. We're going to talk about the reality product family, what we have, and we're going to shed a little bit of light on how the reality works, the different use cases, and we're going to open for discussions. We have tons of demos here, so stay tuned for that. And I would like to start with this slide. Let's get it playing. So what do you see in this slide? There is a video playing, apparently captured from camera in a plane or something, and the quality of the video looks amazing. I think this is in Orlando, if I'm not mistaken. But can you look at that quality? Can you imagine that this is not a video? This is a 3D mesh generated by the ArcGIS reality, of course with the proper data required to produce that. But this is not just a video from the plane. This is an actual produced 3D mesh with a very high quality represented in there. I'll play a very new one that we just produced recently on the reality, and it's favorite for me because I'm from Egypt. So this is also using a black sky data set, a satellite imagery. I think the resolution was 30 centimeters to produce this amazing scene for the Great Pyramids of Giza, with all the surroundings as well. And it's not only limited to that. So you can do much more. So you can produce the reality representation of different cities. This is in Austria. You can produce the 2D, 2.5D products out of that as well, the digital elevation models and the digital terrain models, and so on and so forth. That was just a quick intro with a teaser just to show you what's possible, but let's get back to the agenda. So if you remember the pillar slide that we talked about, the 5 key pillars, there was one here on the left, which is the reality mapping. But by definition, what is reality mapping? Reality mapping is the process of creating digital representation of the physical world around us, using images or LiDAR or both. That's by definition, or according to the book. So what do we do in the reality mapping? Or what's the purpose of reality mapping? To take the data or the captured imagery or LiDAR, not LiDAR, but the captured imagery from different sensors, from drone, from aerial, from satellite, and then generate foundational content. So it generates true orthos, it generates surface model, it generates 3D mesh that would similar to what we saw. So I can use this data that is accurate and ready to be analyzed. I can use it for train analysis, or I can use it for progress monitoring, or I can use it for vegetation tracking, and so on and so forth. And when I run my analysis, and I can infuse also these outputs in an intuitive GIS experiences or intuitive 3D GIS experiences that I can visualize it and see it as well. So this is, in a nutshell, the ArcGIS reality purpose. The workflow or how it works, I have input imagery on the lower left. I take that imagery and I process it and manage it, and then produce the product that comes out of that, and then analyze and share the outputs of the reality. The key outputs that I can produce from the reality are the ones on the screen. I can produce true ortho, that's in the 2D. I can produce digital surface model, that's in the 2.5 dimension world. And I can produce in the 3D world, I can produce point cloud and 3D mesh. Those are the very key components. I'm gonna stress too much. Do you guys know the true ortho? Have you used true ortho? True ortho, not traditional ortho mosaic. Okay, I don't see a lot of hands, but it seems true ortho is extremely, extremely important. Why the true ortho is important? This is a traditional ortho mosaic here. As you can see, there is the object lean. I can see the buildings are not as if I'm capturing them from the nadir where I'm at the top of the building right of that. This can be a bit problematic, right? Because with every imagery update or with every imagery drop, the lean angle can be different. The angle of the capturing might be different, so it can provide different outputs. And if I'm relying on this in a production mapping system where I'm digitizing the foundational, I would have to go to something like stereo to do that. If I'm running an AI algorithm to do the digitizing, that's not accurate. That's going to change over the time. And that's the true ortho for the same scene. Can you tell the difference now as if I'm exactly off nadir of that building? So there is no of the other artifacts or defects that I saw in the previous image. Now if I run building digitizing or building footprint extraction, I can do it properly. And every object or every edge of whatever I digitize precisely is in the same location. If I get a new drop to see if there is any changes or new buildings have been added, I will not get any false positives or incorrect results because of that image object lean and issues that comes with the traditional ortho mosaic. Just another example that to show you the difference for the same building, the same capture. So you can see on the left side, that's the traditional ortho. On the right side, that's the true ortho. If I'm gonna do the building footprint digitization, look at the defect. This is the proper location, but how am I gonna digitize this? Am I gonna start from here? Where am I gonna do the digitizing? So it will be messed up in the case of the traditional ortho. Also, I can build other use cases, like if I'm extracting any other features, like trees, for example. If I have a proper true ortho, that will benefit me big time, so I can actually get the accurate, precise locations of the objects that are in the picture. Enough about the true ortho. That's the second example of the produced output. I can generate something like the DSM that you see in the picture. And the third output that I can generate is the 3D outputs, which is either the mesh or the point cloud. Actually, the 3D looks amazing in the reality because we do a lot of processing, a lot of improvement on the generated output. For example, if we have an input oblique image as the one that you see here, you might see some issues in that generated scene. You can see the moving objects here, which is something I don't wanna entertain the moving cars in my authoritative data because it was just passing by. There is a bit of increased shadow here. There is some moving objects. There is a sun reflections and sun glint on the water. Reality Engine also improves that a little bit by removing objects. I mean, it's not perfect 100% just to set the expectation, but it improves the quality of the generated output significantly. So that's something that I can rely on. Produces different output, and of course, the common question that all the people will ask is, what's the accuracy of the generated output? The accuracy is going to be coming from the GSD that your sensor is working on or relying on. If you're working in the drone world 2 centimeters or lower, then you're going to get that level of resolution on the lower right. If you're working in the era of, I don't know, aerial, you're talking about 8 to 20 centimeters or above, you'll probably be looking at something like this. If you're looking into the satellite era, then probably you're looking at the level of details that's generated from the satellite. And you can use them all, by the way. You can process the satellite, of course, if it has the proper overlaps, or what we call the 3D imagery from the satellite. It can process the aerial imagery, and it can process the drone imagery as well, and produce the different outputs. The difference in quality will be a factor of the resolution of the imagery that you capture. But you can get great, amazing details out of the imagery that you capture. These are different examples at different resolutions to show you the level of details that you can get. Like this is the railway tracks at 10 centimeter, that's what you're going to see. At 5 centimeters, that's what you're going to see, and 2.5, that's what you're going to see. So different levels, different outputs, and different possibilities as well. So that was the first part of our session, talking about what is reality and what is the outputs that we can expect from reality. The next part, we're going to talk a little bit more about the details of the products. So what is the product family that we have within the reality? In fact, we have different products that uses reality engine core technology within themselves. So we have four products that leverages the reality engine. We have something called SiteScan. We have another product called Drone2Map. We have a third product called Reality for ArcGIS Pro, and the same product but a different separate application called Reality Studio. So 4 different applications that leverages the reality engine within them. But the common question that we get all the time, what is the difference between these products? Which product should I pick to process my imagery to produce the output? I think that will be resolved by this diagram. So depending on your area and your sensor, if you're in a site area, like a small area, you are probably using drone. You're not going to use an aerial imagery for like 2 blocks kind of a site, right? You're probably using drone. So if you're using drone, so if you're talking about a site, then you're landing in this product zone. You're going to use either SiteScan or Drone2Map. And in the next few slides, I'm going to talk about the difference between SiteScan and Drone2Map. But those are products used to process drone imagery. One of them is a cloud offering, SaaS, so you can just upload your imagery, hit process, and it will process it for you. And the other one is on your machine. So put your imagery, pass it to the Drone2Map, and set the parameters and process. If we're talking about bigger sites, to a city level, then probably you might be using aerial sensors. Some people might use drones that can span across larger areas. I've seen some customers do that across the globe because of the reduced cost of the drones versus the aerial photos. But you're probably working in one of those territories. If you're using aerial, then you probably, if you're using pure aerial imagery and multi-head sensors, you're probably need to use something that we call Reality Studio, which is dedicated for mapping agencies that receives large amount of aerial imagery and want to process that and want to establish the focused workflow around producing outputs from there. But if you're dealing with a drone, for example, for a larger area, sometimes, by the way, there are limits to the amount of gigapixel I can process within Drone2Map and SiteScan. So in Drone2Map, for example, the limit is 300 gigapixel. Let's say that your site is much bigger than this. We're talking about Neom. We're talking about a massive area, for example, and they capture it with drone. And the amount of images being captured, it's even though it's with drones, but it's bigger than 300 gigapixel. In this case, I'm gonna go to what we call Reality for ArcGIS Pro, which is an add-in on the top of ArcGIS Pro, enables me to process drone imagery, no limits on the gigapixel. The only limits is my hardware. And it can also process aerial imagery, but with the basic sensors. So the advanced, have you guys used aerial imagery sensors before? Are you familiar with Vexel, Citymapper, the different sensors there? So these are the high-end advanced ones, and for them, probably you would need the Reality Studio. But if you're using other types of sensors, you probably are going to use the Reality for ArcGIS Pro. And that probably will scale up to the country level. I hope that clarifies a bit of the clutter around the products to help you choose which product. So there is a path. You ask yourself a question. How many gigapixel? What is my sensor? And then what is the limits of the processing? What is the type of the camera that I'm using? So these questions will help you narrow down and decide which product is right for you. But in essence, the ArcGIS Reality as an engine, as a capability, is in the core of these different products. So all of them, because some people might say, oh, the output of Drone2Map is actually worse than the ArcGIS Reality, which is not true. They are both using the same core engine in the heart and the core of the processing of the imagery. So the output should be identical unless there are other factors, unless there is a different sensor here or different calibration parameters. But the core of the aerial triangulation and the reality processing is the same. If we talk quickly about the products, so this is Drone2Map. It's a desktop that enables me to process my drone imagery. as you can see, 2D and 3D, and produce different outputs. So it's for the people and organizations that doesn't prefer the cloud option. And I know that in Saudi there is a bit of restriction on uploading the data in the cloud, so that's a good friend of yours to use it on your workstation. The downside to this is I need a powerful machine. So I need a workstation, powerful, to be able to process that in a decent time. If I'm not restricted about the cloud, and I just want to upload 50, 100, 200, 500 drone images, process them in the cloud without the need to buy the expensive rig or the expensive powerful machine and pay thousands of dollars, that's my favorite option, because I'm going to upload the imagery, hit process, come back later 30 minutes, or receive an email, and the process is done. So, and I just pay for what I processed. So it's a credit base. It doesn't consume that much credits for simple processing, so that's an option a lot of people leverage. We have a lot of our customers in Europe, in Malta, in many other places that leverage that option. The two other products that we have is Reality for ArcGIS Pro, which is an extension on the top of ArcGIS Pro. So you have it, when you have it, you have ArcGIS Pro with it. Let me show you quickly what it looks like in a video. Just turn this off. Yeah, so it's typically, if you're familiar, you just take it from the new workspace. You start an ortho, where you're starting an ortho mapping, but this is, when you have the extension installed, you will have another workspace called Reality Mapping. Allows you to set the parameters. Sorry. And then load your camera parameters here. I'm gonna just fast forward through the video. Load your imagery. Do the options for the adjustment that you're doing, and then process that. Generate the output and generate the different products. This is the product definition. So what are the different products that I'm going to produce from there? And it's generated for me the 2D ortho and the 2D, 2.5D, and also the 3D out of that. So this is, I just wanted to give you a quick overview, because people like, okay, what is Reality for ArcGIS Pro? How do I access it? So that's just a quick round. We have a lot of tutorials. We can point you to them, but this is what to expect from the Reality for ArcGIS Pro. Reality Studio, by the way, Reality Studio and Reality ArcGIS Pro are coming from one product. So you only need to buy ArcGIS Reality. That's it. You get both. Reality Studio is for large areas, reality mapping, for organizations like the surveying agencies or the mapping agencies, that they receive tons of aerial imagery and they need to process that across the country level. So this is probably centric for those people that are working on the production and don't want to be distracted by something like ArcGIS Pro. You know, ArcGIS Pro has so many functionalities, so many tabs, and we don't want my production people to be confused. I want them to work on the aerial imagery and focus on that. So that's why this is a separate product for them. Let me show you what the product, and this is an advanced photogrammetry survey grade accuracy level. Let me show you what it looks like. So this is, it looks like ArcGIS Pro, but it's very minimum, just like a clean interface, and have the focused functions for me so I can work with my image. Here is loading, creating a session on that, loading the camera parameter, and then setting the projection system, and then it shows me the camera and the different angles of that is captured, the ground, setting the parameters. So these are all the different shots that were captured on a large area. And then the different views, so I can manage the ground control points. There is a lot of great options, and by the way, Reality have been in work in progress, or we have been releasing it for the last 2 years. We have so much improvements that were done to the Reality. Like the recent release, we have something called mesh to true ortho. So from the generated 3D mesh, actually, you use that to produce a proper true ortho to get rid of some of the artifacts that are common in any true ortho generation. So check it out, because there is a lot of great output from there. But this is what the product looks like, and this is what to expect from there. One of the highlights that I want to show you as an output is the satellite processing, because a lot of people don't have that piece, and it's a big deal, by the way, to be able to take a large area, covered by satellite with a proper overlapping like Airbus, stereo imagery or something, and to process that and to produce something like this from the satellite imagery, it's impressive. It's something that was not easily done before. This is, I think, in Madrid, and this is the generated output from the reality as a 3D scene. I mean, people might argue like we've seen better, but again, it depends on the resolution of the imagery that you've captured. If you're giving me 30 centimeters, then the 3D quality expected is going to be the same. If you're giving me 2.5 centimeters, then it's going to be the same. أخبرنا في الوقت. لسه في وقت؟ ماشي. لا قشطة. So that was the part about the product family, how it looks like, and a bit of quick demos. The next section is just a quick intro how the reality works, because there is actual photogrammetry science behind the reality. It's not just pretty looking stuff, it's actually correctly, geometrically correct, and there is a lot of photogrammetry work behind that. From the processing workflow, you take the inputs, the X, the Y, the Z, the pitch, the yaw, the roll, the omega, all the parameters that come with new capturing and imagery. And then you take the additional parameters as well, the camera calibration, if there is any, the GCPs to do more precise corrections. And then you do an alignment process, which is the process of orienting those imagery, what we call aerial triangulation, and then leveraging whatever the GCPs that are there so you can correct the imagery. And then you, after you do the correction, you do what we call construction, which is producing the products that we talked about, the 2D, the true ortho, the point cloud, and the DSM, and the 3D mesh. By definition, the photogrammetry, for those in the room that have done photogrammetry, and I've seen, I see few faces here, is the art and the process of surveying and measuring in a map making by taking photographs, especially aerial photographs. That's some sort of a definition. The basics of the photogrammetry is the light reflections on objects, and then we capture that on a sensor, and then that sensor represents represents what's on the reality. One of the basics of the photogrammetry is the triangulation, which is people that have used the stereo pairs and probably are familiar with that. So this is the 3D perception is something that is achieved through something what we call triangulation, or something that we call parallax technique. By capturing images of the same object from different locations and different angles or different lines of sight, this can be developed or captured from each camera, and then we can link them together. So that there are some coordinates that can be derived from the correlation between the same object but from different angles. So this is in basic what's happening. But in order for this to happen, we need to have proper capturing or flight planning for our images. So we need to have proper overlap. If there is no overlap, how am I gonna calculate this triangulation and do this tie point matching? It's not gonna happen. Because people come and like, okay, I have a single image, produce the reality out of it. It's not gonna happen. I have imagery with 15% overlap. It's not gonna happen. Or it's gonna happen with very poor quality. So for it to produce similar good quality outputs as what you guys saw in the previous demos, we need to have proper overlaps. I think the recommended is minimum 70% in the forward overlap. And of course, this is what it looks like from an overlap. This is one picture, another picture from different angle, and the third picture, and there is at least 70% overlap. The same also should happen from the side. We need to have side overlaps. At least 65% side overlaps should have coverage, so we can achieve a proper generation of the products. And that's what it looks like in the side overlaps. So when we take those overlapped imagery, we do some calculations, and we do what we call tie point matching or key point matching, and calculate the triangulation process. And based on that, the engine is going to be able to produce the amazing outputs that we saw in the previous stuff. I mean, it's very sophisticated. I'm not going to get into the technical details of it, but this is, in essence, or a quick overview, what happens behind the scene, behind the engine. I'm going to take a pause and ask for questions before moving to the demos. Do you guys have any questions or inquiries about the reality? I'll take 3 questions before jumping to the demos. Any questions? Okay, that's fine. We'll keep it. Sure, there's one question here.
Thank you so much.
Thank you.
This ArcGIS Reality requires a separate license,
Yes.
even if you have ArcGIS Enterprise?
Yes, it's a desktop product. ArcGIS Reality as a product is a desktop product, requires different license than ArcGIS Pro, and so it's a separate license that you have to procure and
Okay,
acquire.
even if you have ArcGIS Desktop Pro and then ArcGIS
Yes.
Enterprise, it requires a separate.
It is a totally separate product, so
Okay.
it requires a license. Drone to map requires additional license if you want to use drone. Site scan, there is a different credits license and for that. And Reality is a separate license as well. Because we cannot include it in the core desktop product because not all the people will use it. If we include all the capabilities, then you'll see that the ArcGIS Pro is $1 million. But that's not the case. A lot of people need the core GIS capabilities. Maybe they need imagery, so they get the imagery analysis. Maybe they need to process reality, so they get the reality part on the top of that. Maybe they need to do network mode. So that's how we're licensing the stuff in order to make it kind of cover all the audience.
And
Thanks.
Thank you.
It's a desktop-based licensing model. So you have ArcGIS Pro, you will buy the extension, you will get the Reality Studio as a separate product, and you will get the Reality extension as well. Reality extension will deal with drones, with the satellite data. Reality Studio will deal with aerial photos. Right now we are in the middle of a process to avail something called Reality as a service.
Yeah.
We
Gonna talk about
put the Reality engine or Reality software in cloud, so you will not be asked to acquire like desktop version of the Reality. You will do all the processing in the cloud, and it will be like subscription based.
Yeah.
It will offload the hassle of management, these kind of overlapped imagery, stereo imagery, and it will be stored in the cloud. The process will be stored will be executed in the cloud with a parallel processing manner. So you will get all those of like the point cloud, the true ortho, the 3D mesh in a very significant time frame.
Okay, thank you.
Thank you.
What I understand is, when we get a licensing for extension of Reality, it will work with ArcGIS Pro. But
Yes.
with the server side, this is on the desktop side.
Reality is not a server-side
Yeah,
product.
this is on the server side. It will collaborate or communicate with the
Yeah,
image extension, ArcGIS server image
once
extension.
you create your 3D mesh, your point cloud, your true
Can share
ortho,
it.
you will be able to publish it
Yep.
to either ArcGIS Enterprise or ArcGIS online as an image service.
Thank you.
Thank you. So let me show you quick another question. Okay. Said I'm gonna take. Yeah, sure. Please.
Thanks. I want to ask about if I need ArcGIS Reality, I can an enterprise or image server.
It's not available right now in enterprise or nor in image server because we don't have the processing engine
In the enterprise.
In enterprise right now. We are doing this right now, but it will be more scalable in the cloud.
Okay, thanks.
Yeah, there is a slide coming talking about the different pattern of deployment of Reality, and on the right side you will see the deployment pattern on the enterprise, but it's coming soon. Reality engine coming into the.
If I need make analyzing, I have image server.
Yes.
Okay.
I mean, the output of Reality is 2D, 3D. You can fuse them to the enterprise. You can share them to the enterprise and use analysis on the top of that. There's nothing preventing you from doing that.
Okay,
Yeah?
thanks.
Using or analyzing the data that came as a result of Reality, it's open. Again, it's at the end of the day, it's image service. You can have it on ArcGIS Enterprise or even in ArcGIS Pro or even ArcGIS Online and do all the analytics you need.
Okay, just one question.
Thank you.
Does it also support the LiDAR data processing?
Can you repeat? Sorry, I cannot hear you.
LiDAR data processing.
LiDAR.
Yeah.
Reality does not take LiDAR as an input.
Reality does not take LiDAR for the time being.
Yep.
We are working on this, but we can take LiDAR to enhance the positional accuracy of the data.
As an input.
I mean, LiDAR is supported within the platform, so you can still use it as another data source, and you can do some steps to improve the quality, but it's not part of the processing back-end engine.
In that scenario, that means if we are using LiDAR data, we have to finalize the LiDAR data in another environment and use in reality as an input.
Exactly. We have like a separate data model dealing with LiDAR data. It's called LiDAR dataset. We have even our own compressed file format for less data. It's called ZLess. It compressed the last file like 90 or 95%.
Okay, thank you.
Thank you. Thank you. So I'm gonna resume for the time being, and then at the end we're gonna take more questions. I'm gonna show demos now, my favorite part. Okay. Let's start with this demo. So this is a 3D mesh, and it's produced by us, by the way, for Stuttgart. This is the quality that you get. The data was processed. This is an aerial imagery. Was processed with Reality Studio. But you can see the level of details and the quality of the mesh. Not biased to Esri, but Reality is, I would say, the top product in the market, in the mesh, in the 3D mesh quality as an output. So this is one demo. I'm gonna show another one because some people actually work, as you saw in the plenary, in the conservatory or the restoration efforts or tourism. So outside from the cities, they were also asking, like, okay, what's the quality like if we go to a park or a national park or some rural areas? So this is also another scene was produced. I think the data that was used here was drones, and the quality, the resolution of it was 2 centimeters.
This is not a video captured from a plane. This is like 2D imagery, stereo imagery. We take it in reality and produce this 3D mesh. 3D mesh, meaning that I can use this mesh in analysis as well. It's not like just video.
Actually, let's see it live, because I think live will remove all the doubts from the people. So you can see here on the right-hand side, according to the sensor, and probably you need to help me because I cannot see it well. This is the drone, right? Okay. I cannot see it. Stand, let me bring it here. It's okay. Sorry guys, the screen is too far. Okay, so I'm gonna filter out. So the first filter is drone. So this is a drone scenes. Let's go to one that is gonna show like a park. Okay. By the way, this is public. I can share the link with you. This is different produced outputs from the reality, so you guys can go and check it out. But this is 1 centimeter captured using GeoAI metrics. Still loading, of course, but let's wait and see what happens when it's loaded. And forgive my internet connection, it's not the best. But you will see that the rendering is extremely fast. So you see the level of quality that was produced here. For anyone that is working in the geological world or working on the exploration, if they fly drones or if they fly different sensors, they can actually capture and produce the output. And by the way, this output is analytical. So I can measure areas and volumes and do visibility analysis on it, you name it, slice through the analysis and everything. So this is an example from the drones. Let's take another example of the aerial. My favorite one is Boston. The quality of the output there was impeccable, so it's very good. Do you remember in the previous slide, in the first session in the morning when you talked about imagery access, there was something at the bottom called I3S, which I said it's the 3D tile streaming protocol that we have. This is 3DS. This is streamed in 3D, I3S. You see how fast the rendering happened, and it's not stored on my machine. And this scene is probably 20 gigabytes or something. But you see the quality of the produced output. This is using the city mapper 2S, and the resolution is 4 centimeters. So look at that. Let's go to this one. It does a progressive loading of the data. So it will show you like a coarse version of it, and then progressively will improve the quality once the connection stabilizes or gets better. I think I jinxed my connection, yeah, but you see it's improving now. So this is the quality that you get with the reality, and it's, as you saw, it's live. It's not something that we made up with this. Lots of other stuff. Just for the sake of the time, I want to jump to the last piece of the presentation and continue the session and open for your questions. So we saw the product, we saw how it works, we saw the options there. Where does it stand within the platform and the different use cases or the possibilities? So this is the slide that I was referring to earlier. The deployment options, you can have it in desktop and SaaS, we talked about this. You can have it as locally distributed processing, which is something available for reality. If you have multiple workstations, I can actually parallel process the reality operations on different machines. They connect via TCP/IP or some COM port connection, and then they can parallel process that between them locally. What's gonna come up next is reality that is gonna be for the enterprise. So we're gonna call it ArcGIS Reality Server. Hopefully that will not change, I don't know, it might change. And there is also another thing where we call it ArcGIS Reality Processor, where we can put it in a SaaS cloud. You can deploy it in your own preferred cloud, and then process the reality images there. To give you a sense, reality, the aerial imagery processing takes a lot of time. To capture a city, it can be 150,000 aerial imagery. Processing that on typically would take a week, or would take even much more than that. It can take a month. But when you leverage technologies like parallel processing, like distributed computing, you can actually scale and fasten that up a lot. I just wanted to give that in terms of possible, or where does reality stays within the platform. What are the possible use cases? And that's the last section of my presentation. You name it. I mean, we produce the raw output, right? But you can put it in a context that would make sense. It can be used in environmental, it can be used in urban planning, AEC, utilities, or real time, and integrate that. And you can use it for different phases. So you can use it for plan and design, whatever you're working in AEC. You can use it to analyze. You can use it to use simulation. If you want to simulate the flood, reality is going to be a great addition because you're going to see things in 3D. You can use it to inspect. If you're a company, utility company, and you fly drone, and you want to inspect your cables, and you want to inspect your towers, that's something that you can rely on, and nothing better than a photorealistic 3D representation to show that. And the last one is operate and maintain. The next slides are going to show these different themes. So this is in the planning and design. This is the output of reality, but I'm using it in planning and design. This is ArcGIS Urban. Now I am proposing to do a new building. What's it gonna look like? And which design is better for this environment? So I can see the existing infrastructure and the proposed design. It's helping me. I can simulate the shadow to see if that building is gonna impact the surroundings or no. I can do a lot of the stuff. What type of building, what usage of that building, what's the building code, and so on and so forth. The next one is another one of plan and design. I'm gonna fast forward that one. Sorry. But it's basically taking objects, like 3D objects for a port or something, and where you want to plan that port, and then capturing the actual representation. This is captured by reality. So this is as designed versus actual. So you can compare, this was, I think, a refinery or something, and this is the actual level of details that you capture. The next one is about the analysis. I have the traffic accidents. I want to see them. How about I see them in 3D? Doing that light effect to get the hot spots within the 3D, so I can actually get a better understanding why they're happening too often or too frequent here. This is an example of that. Also, I can do other analysis like the solar suitability analysis to get what are the rooftops suitability from a solar ability perspective, calculate the sun projection on different rooftops. So this is something that I can leverage, and when I present and visualize that in 3D, I'm gonna get another dimension and another understanding to that. Another example of analyzing This is combining the reality output with an app that feeds different information, real time and non-real time, about the current, this is I think from Switzerland, showing us the current attractions and the current sightseeings around us, hotels and everything. Another example of analyze and simulate in this case, I think this was done somewhere in Japan, where they actually simulated the air movement and the dispersion of different gases around the city. So you can take that output and produce it and show it. As we've talked about, the shadow is something that you can do. Have you guys heard about the new simulation model that we have in ArcGIS Pro, where you can simulate a water intake, whether it's from rain or it's behind the dam, and then you can simulate that. If you combine that with 3D, it's going to be amazing, because you're going to see how the water is going to progress. This is, for example, an aquifer or a water reservoir. And then now in the simulation module, which is a module, by the way, if you haven't checked it, in ArcGIS Pro, that allows you to simulate what's going to happen in certain circumstances. If the rain comes with a certain flow rate, or if the water breaks from a lake or over discharge a certain board. So when you simulate this and overlay it with the 3D output, it's going to give you a different dimension and different context to understand the layout of the ground. You guys get a lot of rain here. How about we simulate that? How about we simulate that with a city that have the 3D model, so you can see the impact of that rain on the different aspects of the city and the buildings. So the possibilities are limitless. I mean, I can continue on and on, but this is another simulation of the flood. I know that we ran in time, but I want to give you 4 or 5 minutes for questions. I'm just going to quickly run through the demos. Another simulation example. You see the possibilities there. And third one, this is in the inspection and maintenance. So when I capture a site using drone, for example, one of the outputs that I can produce is oriented imagery, or this street view-like imagery. So I can actually combine that with the 3D model and link them together. So if I want to inspect the towers, if I have enough resolution in the image, I can actually look and see cracks and see any things that I'm interested in, and based on that I can mend it. Imagine doing this for your factories or for your assets, instead of stopping by one asset, capturing it with something high resolution like a drone, super fast, and then analyzing and bringing that to the office. And on the top of that, in this, I can combine this with an AI algorithm that can detect cracks that I'm interested in. So full automation and full speed on time saving. Another one of augmenting the 3D scene by adding augmented reality that shows the underground utilities. So I can see through and see the underground utility in correspondence with the 3D on the top of that. The last example that I'm going to show is again from my favorite Boston, but we took that Boston data, incorporated with the data that shows information about accidents in real time and about the bus movements. So I can, in a dashboard or an operational room, I can understand the situation of what's happening. So this is pulling the real-time data of, I think, different transportation buses, showing us where it's currently at, how long will it need to reach the second point, maybe overlaying that with some accidents data so you can understand that situation. And imagine yourself in a traffic department control room, seeing that view, understanding the real time, seeing the 3D city, and then taking decisions on based on that. That's very, very powerful. I have more other demos, but I would take a hard pause to give you guys some questions. I hope it was eye-opener for you about the reality and the possibilities there. Thank you for attending the session. And I would like to open for questions if you have any questions. If not, then thank you for attending. Anyone have questions? Any questions? We have one question here.
Can we generate 3D tiles from using this platform?
The 3D tiles are generated using the create scene layer package within ArcGIS Pro. So it's separate than reality. Reality, one of the products that it produces is the 3D, and it puts it in the SLPK format. So it already generates the scene layer package for you. And then after that, you can publish it. The function itself is in the core ArcGIS Pro functions. It's not something that comes with the reality.
I have one more question.
Sure.
Can we integrate or import Google photorealistic tiles?
Oh, you're just, do you have insiders in Esri? This is coming up, actually. Okay. We're not supposed to announce it, but I think this is something that you're going to see throughout the year, where you can actually pull them inside ArcGIS Pro. Okay?
Thank you.
Thank you. Yes.
Assalamu alaikum.
Wa alaikum salam.
Is any of these softwares has a limitation with megapixels? As you know,
yeah.
Some sensors
yep.
Started from 45,
yep.
60
yep.
till above 100.
Yep.
So.
Yeah, so I talked about this when we were selecting the product. That's a good question. Sorry that if you missed the explanation. The side scan and drone to map have limits on the gigapixel that they can process. So drone to map have a limit of 300 gigapixel. And the side scan, I don't remember the limit, but I can check for you. Reality doesn't have limits. The only limit is your hardware. If your hardware can tolerate and afford, then you're good. Okay? Thank you. Any other questions? Okay. Sharif, okay. Oh. That's a paid for question.
What about City Engine? Is there like integration to get photos here and have the model and then use it directly in City Engine?
City Engine is a different story. So reality is taking the photos with the proper overlaps, creating a mesh. That's the output. In City Engine, you take a data model, like a multi-patch, and then you start creating the features out of it. So you can put the building facades, you can skin it, you can do the streets, but they are stored in a geometrical feature, unlike the mesh. Mesh is a different story. How can we integrate them? We can put them together next to each other. That's the common practice that it happens. City Engine is actually very powerful because it uses something that we call rule package design type of attribution, and that's why a lot of the
rule of thumb. City Engine for modeling, for design,
yep.
for proposing solutions and scenarios. Reality for reality.
It's reality, the actual reality.
Capturing the as-built.
Yeah.
Thing. So,
thank you. Thank you. Shukran al-Mu'at. Any other questions?
If I will use satellite image, how can I do the overlap or?
That's when you, so when you, there is some requirements when you're requesting satellite imagery from Maxar or Airbus or any of the other providers to have certain overlaps. So there is a document that we published that tells you about the requirement from a satellite perspective in order to be able to produce reality outputs from the satellite data.
Usually when you purchase data from different satellite vendors like Maxar or Airbus, they have different outputs or different products. One of them is stereo products. So they will have characteristics telling you the percentage of overlap, the side overlap, and the directional overlap within their product itself, which is stereo. Airbus doing this, Maxar doing this, Planet doing this.
Yeah, thank you so much.
Just wanted to show the last thing here. Actually, I cannot see. Sorry. So the same scene that we saw in the video of the pyramids, I wanted to show you in close details what it looks like processed in the reality. So where is Sphinx? Sphinx should be here. Yeah. So this is the same output produced in reality. Look at the level of details that is produced with. And this is a local example because a lot of people say, oh, Boston, it's outside, doesn't happen in our region. No, this is from our region. And we have other regional examples as well for cities, Kuwait, Qatar, Abu Dhabi, that are using reality to produce outputs. It's exceptional. So just wanted to show you this before handing over. Any other questions? Thank you so much for attending. If you have any additional stuff, we were happy to connect with you. Thank you so much.
تيست واضح كويس واضح الصوت تيست تمام اوكي الصوت مش طالع كده الصوت الفيديو مش طالع
محتاج بيت من دورين ومتصل بشبكة الكهرباء والمياه والصرف الصحي.
اجرب تاني
محتاج بيت من دورين ومتصل بشبكة الكهرباء والمياه والصرف الصحي.
اوكي اوكي
محتاج بيت من دورين ومتصل بشبكة الكهرباء والمياه والصرف الصحي. تعال ده
نبدأ. السلام عليكم ورحمة الله وبركاته. Hello everyone. Really thankful to meet you today face to face and talk about how AI is changing the geospatial analysis. Ahmed Nuruddin, the AI and industry lead at Esri, Saudi Arabia. Today we'll start with the AI in ArcGIS, which including AI assistant, LLMs, AI agents, and GeoAI. We'll explore how AI integrates with geospatial data, data science or geospatial data through the ArcGIS. We will warm up with the summary and open the floor for your questions, and I'm excited to cover all of this topic today with you. Let's start with the ArcGIS is a comprehensive system for spatial data science, including data engineering, visualization and exploration, including as well spatial analysis and AI capability, our topic today, and including as well the big data analytics and visualization. ArcGIS is a powerful platform that includes, integrates, and deliver AI. So we gonna explain about including and integration with AI, or different systems of AI, how we can deliver AI through ArcGIS. ArcGIS is it has a combination of features like AI assistant and tools like GeoAI tools within our system. So we'll start with generative AI or Gen AI. We have an ArcGIS a semantic search capability or feature is an advanced search technology that understands the intent and meaning behind your query, not just matching the keywords. Like this, combine the table of the two inputs. Here is the relevant response from assistant, including in ArcGIS Pro. As well, a lot of us working with the analysis scenario, but we want to know which is the next step, or which the tool I use for next step. So after running the tool, the geoprocessing tool suggestion to help you which the next tool should you use to complete your spatial analysis or complete your case. This is save your time and make your workflow smoother. We talk about we integrate or include AI included in ArcGIS. So we'll now talk about AI assistant in ArcGIS survey 1 to 3. Instead of creating your form by drag and drop item, we just type a prompt that what you want from this survey. The AI assistant will create the survey for you. Let's watch this demo. I'm gonna use AI assistant included with survey 1 to 3, but here I'm typing in Arabic. محتاج ان انا اعمل استطلاع على الاماكن او الاشجار المسببه ريسكس على الطريق. It's fully supported Arabic language. Here is the response from the assistant. If I'm good with this response, I'm generate. But if I need enhance the response from the assistant, here I want to change the question number 3. محتاج ان انا اعرف المزيد من الاشجار. So the assistant will with the a new response. I'm okay now. Just click on generate. The assistant will generate the form for you. Here is the form fully supported Arabic with the location with different questions in this. I can from right hand side. I can drag and drop any additional item to this survey. Another capability, the powerful of computer vision in assistant. Here is the survey. Want only to extract the diameter numbers from the image, so I will use the capability or computer vision capability with AI assistant to extract only the text from the diameter. Here is the example. I have a dashboard. Just drag a multi-line text and to configure this to configure it to fill out from the image. Here is the configuration steps. From photo, to fill out from photo. I'm ask assistant to assist me to extract only. Here is the prompt. Please extract only number as an integer number. Once I finish, I can publish this survey form, and when I upload any image contain diameter, extract only the number from either end with 70, 28. So we talk about the AI capability or generative AI capability in ArcGIS, ArcGIS Pro as a semantic search, or Survey 123 as an assistant for creating the form itself or extract information from images. Another example, I'm gonna talk about the AI agents. It's easy. We know the LLMs. All of us hear about LLMs, this large language model. So I am gonna use a lot of large language model as an agent to split my work. The output from the first agent, it will be the input for the second agent. So this scenario, I have a sum of layers contain house pricing, street widths, and house height. So use the first agent to transform my voice to text, speech to text LLM. It will be output. Then I will take the text from the first agent. It will be input for the second agent. The second agent will take the text, English or Arabic text, and transform it to Python script to allow me search in the database and response or with relevant data in this from this data. Here is an example. I leave it because I'm recorded this example. I'm use my voice here. I'm used AI agent. I split my work to every agent work on a small task. So first I'm loading the data, did some preparation and rendering the data on the map. As you see, all of houses with different price, with different height, with different probability. The next step, I will leave for the voice.
محتاج بيت من دورين ومتصل بشبكة الكهرباء والمياه والصرف الصحي.
As you can see, the first agent transfer my voice to text in Arabic language. The second agent take this text and search in database. Here is only the two floors houses. To make sure the accuracy of this idea, I print the table of relevant or the search results. It is two floors with different price. So the next question asks, I want to low price house.
محتاج بيت من دورين متصل بشبكة الكهرباء والمياه والصرف الصحي ويكون رخيص.
Here is the low price in Arabic. See the variety of price now. All of low price, the east of the city, at the east, and the table contain only the low price house. Another one in English.
I want a low price house has 3 floors.
I'm asked to search for low price house with 3 floors. Here is the first agent, speech to text agent. The second agent is for give me the result about the 3 floors and different price. Here is the generative AI or agentic AI or AI agents. So
I want a high expensive house has 2 floors.
only 2 floors with high expensive land. So quickly recap what I said. I talk about generative AI included in ArcGIS Pro or some of our products like ArcGIS Survey 1 to 3, or we can integrate with LLMs to support or assist me for searching for doing some tasks. The last one I will show at the end of this session, it's integrated inside our product for text classification. Now I move forward to talk about GeoAI, Geospatial Artificial Intelligence. It's about extracting information from remote sensing data, satellite imagery, drone data, CCTV cameras, whatever the type of data, as well from feature layer or feature classes, which we call vector data. So GeoAI term come from the combination of AI and spatial analysis to allow us to understand more or extract more information from different type of data like imagery, like text, like vector data or tabular data. So we have 3 data modalities: image or remote sensing data like imagery or image from different type of sources like satellite, drone, aerial, CCTV, or we have a data as a tabular data like layer, feature classes, feature layer, shape file, or we have a data from in shape of unstructured data like text, Word document or PDF document. So GeoAI can work with all of this kind of data. We can perform a computer vision tasks to extract information from satellite images or drone, like object detection, pixel classification, object tracking, or we can working with tabular data to make a predictions or forecasting or make a classification or clustering. We can working with the text type for reading or extract entity from unstructured data like street names, buildings numbers. We can extract this information and visualize on the map. Here is some example of real world. All of us, I believe all of us working with building footprint. How many? Who working with building footprint? Okay. This is used GeoAI for extracting building to identify where is the location of each building. But this input or this output, I will use it as a to complete scenario to find where the most or the high risk building. Make some raster analytics to identify or classify the landslide risks. So once I use AI to extract the building and remote sensing or raster analytics to classify or identify where the risk, now I know where the building in the very high risk of landslide, as you can see in 3D visualization. Another example is for change detection. Change detection for everything, for tree, for building, for streets, for constructions, for urban planning. We have a old image from 17 and the new one from 23. So from this image, you can identify that it was changes has happened, like because a lot of cutting here. But I want to know how many, counting the object. So I'm creating a deep learning model to extract or detect and counting the tree and run this model on the both images. Here is the final result. From 23, it was more than 100, but from 17, it was more 700. But I know now where is the cutting. The red polygon identify where the cutting done. Now I know how many cutting or removed tree from. So I'm use the deep learning to identify the changes. Another example for monitoring. In both videos, it's the same model. This model used for object detection and declassification. Detect cars with classification type of vehicles, cars, buses, trucks. This is a fixed camera or street and detect in real time with updating the dashboard, as you can see here. The same model used for indoors. I draw a green area. This is a safe area. Anyone inside this or dangerous area, depending on your scenario, anyone inside this area will be detected, as you can see there. So where the GeoAI capability in ArcGIS? We have three options. You can use pre-trained model. This is, we train a model and it's prepared for you, or you can use our tools. This is out of the box tool, no need for scripting. Or if you would like working with scripting and create some custom models, you can use our ArcGIS API. Where I'm gonna get on a pre-trained model from Living Atlas, in our ArcGIS Living Atlas, we have more than 80 deep learning model that work on different industries like conservation, natural resources, and utility, and perform different tasks like car detection, land cover classification, chip detection, tree segmentation. So it's easy to go through Living Atlas and download this model from there. Here is, you can, from Living Atlas, just search about DLPK, all pre-trained deep learning model, it will be here. Once you determine or you choose a proper deep learning model for you, you will see the a fully details about this model, the accuracy matrix, the input, required input, the output will be, and some of screenshots. There is another one for root extraction. So just go to ArcGIS Living Atlas, search about DLPK, and choose which one will fully description. Okay. For pre-trained model, I recommend to go first to pre-trained model, because it will save a time for training, for collecting data, or sample data, for inferencing and for testing. If you have the same scenario, if you have the same case, it's highly recommended to use the pre-trained model. But if you have a different scenario, in ArcGIS Living Atlas, we have a deep learning model to detect cars, but I want to detect trucks. I want to detect a different type of tree. So you must create your own model now. But again, I highly recommend to, if you want to create your custom model, I highly recommend to use the tool. This is will save a time. No need to know more about the science behind this tool. Just add, set the parameters and leave the tool to work for you. Let's start with the GeoAI tool for imagery and 3D. I know this is the imagery track. You hear more about imagery from Dr. Walid or from my colleague Awadi. I'm just talk about the tool. But would like to talk about this slide more. Anyone working with computer science or data science, working with object detection and computer vision. In computer vision, we have 4 techniques: pixel classification, or object detection, or innocent segmentation, or image classification. This is a 4 techniques for computer vision. The same techniques we applied or implemented on remote sensing data. So, pixel classification we used for land cover, object detection we used for tree detection, car detection, whatever. Image segmentation we used for building footprint, and image classification used for classify image between damaged or undamaged building and some if there any crisis. as my colleagues mentioned before, we have a lot of different formats from different sources. We have 3D scenes, motion imagery, 3D point cloud, overhead imagery, time series imagery, or oriented imagery, with different type of tasks like object detection, 3D object detection, for pixel classification, for tracking. So ArcGIS support all of this type of or data format, as well with the different tasks. Here is the end-to-end workflow, starting from different sources, satellite, drone, CCTV camera as well. ArcGIS will fully support you, starting from accessibility or data access, preparing your data for sampling, labeling, drawing polygons or bounding box around the target object, training your model, deploy the model on production or to production. Once it's deployed, everyone in my organization can consume this model to do or perform their analysis and run at a scale. Once I have a feature layer from the model, I can easily take action. I publish as a dashboard for decision maker. So if I wanted to create my own model, I have 3 steps all. Data preparation, model training, model inferencing. For data preparation, after my teams or perform image management, now I'm working on top of them, of this task. After management and the mosaic, etc., I work on top of this. Just labeling, drawing polygons around the target polygon, to target object, use export training data, the geoprocessing tool ArcGIS Pro, as well as the same tool in ArcGIS Enterprise. Now I have a sample data or data set, so I can use train deep learning model. This is for training the model. Sometime it will choose or select the proper neural network for you. Don't worry. We don't need to know more about the science behind this tool. If you want, it's okay. If you don't want, خلاص. You can move forward direct, but just add some or set some hyperparameters and leave this tool working for you. Once the tool finished, I can use the output from this tool. It's a tool, a deep learning model package, the DLPK file, and run it on different geographic area to make sure this model working fine for my case or my use case. Again, now I understand the tool, but where is the tool exactly? For ArcGIS Online, we need ArcGIS Image. For ArcGIS Enterprise, it's a powerful application, deep learning studio with image server as a back-end server. If I want to work as a standalone or individual person, can use ArcGIS Pro with image analyst extension and some additional extension like a 3D analyst and the 3D base map. In this demo, I will showcase the powerful application ArcGIS Enterprise. Deep Learning Studio is a project-based application. It's end-to-end deep learning pipeline. So from scratch, you will create your own deep learning model without need of any scripting. But what's the benefits of this application? It's organization-based, so it's multi-task, multi-user. I can assign a task to team members, and I can follow up, and I can as well make a QC for or on the sampling process. Let's see. Here is the demo from ArcGIS portal. Choose Deep Learning Studio. If I have a previous project, will be here. If I want to create one, I create a new one. Field boundary detection. It's mandatory to select the project type before your work. Object detection, pixel classification, as I mentioned before. So creating now. We have 3 steps, as I mentioned before: preparing, training, inferencing. Click on preparing. Okay, here is select the image surface and the class name, or for this is for target object, and the group of work. If I assign the work to a specific group in my organization, here is the assignment. So I can trace every step in this application to make sure we work within the table. Now I have a drawing a capability to draw the samples, just polygons around, or polygons on the required field. This is for QC. I have a dashboard, all samples done. We have a dashboard, and the QC or team leader can approve or reject the samples. If sometime maybe some employee drawn wrong. Here is an example. So this is for QC team. Approve this one by one or approve all, but I have a incorrect one. So I reject this. Once the QC team finished, now we have a layer of polygons that contain the boundary of fields. Here is the tool for export training samples. Here is the exporting process. Once here is the image chips, the result of the export process. Now back to the next step, or the second step is the training model. Just here make sure which folder. We have 3 folders, but I only train the model on one folder. Once I click on the folder, I can see the image chips there to make sure that the correct folder. It will take a time. This process make sure you have you have a proper machine specs for this process. Once finished, I have a report for the training process, accuracy matrix, validation and the training loss, and the comparison between ground truth and the prediction result. Now I can publish as an item in ArcGIS portal, so everyone in my organization can access. If they have a privilege, they can access on this model. And the third step is inferencing or detect object. Just select the published one and leave it. It will take a time as well, depending on you, the extent or the area of study, depending on your machine. But the powerful of this application, it will work as a parallel processing. So if you have a lot of machines or multiple machines, it will take the advantage of this multiple machines. Here is the result of the field boundary. For 3D, for 3D, we have a capability, ArcGIS have a capability to working with point cloud or 3D data to classify point cloud or to detect 3D object, like classification of wires and pools, building classification, point cloud building only, as well for 3D object detection. As well, we have a capability, ArcGIS have a capability to work with tabular data like layer or feature classes, capability to work with the time series data like weather data or climate data, working with the text data. So, and ArcGIS we have in ArcGIS a toolbox, a grateful toolbox, GeoAI, that will work with all different data type. For tabular data, for imagery, we talked about it before, for text analysis and time series. This demo, we will use the powerful AutoML. AutoML is a geoprocessing tool that choose or working with different machine learning algorithms for you. No need to study or explore the difference between each machine learning. This tool will do this work for you. Just set your data, leave it the tool work 2 hours, 3 hours, and it will give you all details about the training process. In this example, we will use AutoML tool to predict ride share demand. So we here looking at a data set, and yellow area indicate a higher ride share demand. If I click, I can see my dependent variable. For machine learning, we need identify the dependent variable and independent variables. So dependent variable here is the trip count, and another independent variable is different item. As well, we have a set of land L stops, location, and raster to density of crime. So the factor for this prediction, we have a GIS data or non-GIS attributes. So my goal here is to train the model on these data sets and use it in different location. Here I'm gonna use AutoML. I specify input for feature layer, and where is the dependent variable? Here is the target variable. Okay, it is the trip count, and as I will also pass my independent variable different with the different. Here is the independent variable, all of the different items. As well, I identify the distance and the raster. So the tool has, this tool has 3 modes: basic, intermediate, and advanced. If you click on question mark, you can read more about this different modes. So the tool contains a lot of machine learning algorithm, from decision tree to a state of art of a new machine learning algorithm. I'm not actually going to run the tool. I have I run it before. Here is the algorithms. Once I run the tool, I have a predicted here. So I will apply the tool after the running. It will take a time. Here is the result. See where is the predicted hotspot area, and the comparison between the different algorithms or machine learning with the accuracy matrix, with the all information you need about this training step. So I'm gonna use the model in different city, Philadelphia, to predict the rate share here. I have not a data for rate share, but I have the same independent variable, raster for crimes, L stops from public transit. After I run the model on the new area, here is the result. Just to make sure to match the independent variable here from training old one, and this is from new data set. Match the columns. Here is the result of the predicted right share area. It will be middle on it will be the yellow area here. So we train the model in Chicago data and predict in different city. So you can use this model in different another city. Again, we working with the imagery, with tabular. Now we will working with the text. Short or we can use LLMs to classify, or for text classification, I'm scrapping some tweets from X, and I want to classify this tweets. So just a few lines of Python script. I am use open source LLM Mistral and write a prompt, classify all of this input sentences into defined label. I constrained or bounded the LLMs to only use my examples. Emergency like this, critical public information like this, or others like this. Once the model finished, I have a classified text in this column there. I know this is some blank area because maybe not included to the three classes. So we talk about the capability. You can use a pre-trained model. You can create your own or custom model using out-of-the-box tools. Or now, if you want to work with the Python to create your custom neural network as well. Anyone familiar with deep learning? Use it. I believe he used PyTorch, TensorFlow, Keras. Here is, if you want to create a neural network, here is a lot of lines. Some developers create a high-level libraries. Lightning, it's encapsulated little bit the PyTorch, but in ArcGIS we did more encapsulation. If this is maybe 50 lines, in ArcGIS you can create a model from scratch in only 6 lines. Here is the last one. This is a full code or script to create your custom model. Just 6 what's coming, what's new in GeoAI? We working on a lot of LLMs integration and embedding LLMs in our system to create more advanced or more accurate AI assistant. As well, we working with multimodal AI. It's multimodal. The idea of multimodal is input will be different, text and image. The model can work with different input like text and image, and take a decision and response about our response from this two different type of data. A new capability as well is image description. From this image, if I ask about this image, the model will tell me about what it see. The model see aerial view of marina. This is full description. Maybe required in GIS, not, but it is some enhancement in our model. You know, GeoAI is now supporting or helping us to address more complex, to solve more complex problems in different industry. We're gonna summarize what happened today. The powerful of deep learning was the sum of the end-to-end workflow and the powerful of GUI experience in ArcGIS using ArcGIS Pro or ArcGIS Enterprise, as well the Python API for data scientists. Here is some material. I'm sure this is very good for you to start from here about using AI or creating your model from scratch if you want to using ArcGIS Pro or Deep Learning Studio. I know I'm talking fast because my screen tell me close to an hour, but it's not real time. Sorry, I'm talking fast. So please scan the QR and share your feedback. And if now the floor open to questions. Anyone have a question? Okay.
Thank you, Dr. Ahmed, for this useful presentation. I would like to ask about the label or training for many features. As we know, it's maybe difficult to know the classification.
صوت مش سامع. شكرا منصور. لسه مستنيين الاسئله.
لا شكرا دكتور احمد. يعني سعيد بالمحاضره ديت. يعني احنا لما بنعمل تريننج اريا بيكون في عندنا مشكله في التريننج دي ان انا عايزها جاهزه. لو انا عايز اعمل classification, if I need to do classifications, I need to training ready, made before FAO international organization. How can capture this organization and get the fine result?
Okay.
So for example, land cover, I need land cover high training and high result.
Okay. We have a two approach.
To apply for Saudi Arabia, for example.
Okay. We have a two approach. If we have a sample data, ready sample data, you can use it directly to train using ArcGIS. Yani if you have a sample data from different organization, it's more welcome to use it in ArcGIS to train the model. But if you don't have, or different for land cover, no ice class here in Saudi Arabia. Okay, so you can create your custom data set using ArcGIS tool to draw and identify each polygon belonging to each class. So but we have a tool. If you have already, or you can create your data set. The ArcGIS it's facilitate this. This is a more headache process, sampling. But ArcGIS Pro, it's just drawing a bounding box or drawing polygons on this. Okay, thank you. شكرا لكم. نعم. ممكن هنشاركه معاكم ان شاء الله. موجود على قناتنا على اليوتيوب. على العرض ان شاء الله نحاول نشوفه باذن الله. اعتقد هرجع بس للماركتنج تيم ونشوف يعني الآلية كيف بيبعتوا لي الناس اللي سجلوا ولا بالانفيتيشن، يعني هشوفها دي. لا طبعا. اتفضل. شكرا. باذن الله. الله يعطيك العافيه. شكرا له. ان شاء الله. الله يعطيك العافيه. شكرا لكم. شكرا. Have a question? Okay. خلاص ما فيش مشكله ان شاء الله. لا عادي. شكرا لك. باذن الله. Okay.
First, I want to thank you about this presentation. It's very good, mashallah.
Thank you.
I was asking about, recently I saw some symbols for the training model from Trimble. Something that this model was detecting for the parcels, but not detecting, is drawing the parcels. I asked about if Esri have something like that.
For parcels?
Drawing the features, not detecting about that. Drawing it in real time, not detecting the features.
Not detecting the feature, but
drawing it.
Drawing
yes.
it. Okay.
Because I saw something like that in Trimble, so I would ask
drawing
the parcels.
The parcels.
Yes.
I'm not sure we can ask Mansour for this. I'm not sure we have a capability to drawing, not extracting or detecting, but drawing. How gonna to draw? Just typing a command and it will draw?
Yes, I saw it like you input some parameters for this model, and then you identify the imagery for this model. Then he detect the parcel first, then he drawing all the parcels here. But itself, there is no need to help this model to detecting.
We have a model text SAM model. Maybe do the same task. Just prompt the object and it will detect, like drawing, all object in the image. Only what you write for prompt. يعني detect only cars or يعني I will share with you for detect a kind type of car, color or red car only, it will detect or red car only.
Yes, this is the new
the
reasonable model for this.
Yes.
But about the drawing?
Drawing, I'm not sure. Mansour, I will talk. You ask about drawing.
أنا عندي شوية قطع أراضي. Okay. I have some parcels.
No.
Okay.
الله يعافيك.
Yes. Okay, and I need now. I want to not detect these parcels. I need to draw it.
شكرا.
Yes.
لا خلاص.
As a human workflow. Yeah, that's my question. Is there some models for Esri do something like that? Because recently I saw some models from Trimble do something like that.
I don't think we have parcels model in one of our library. We have building footprint detection, road detection, and stuff like that. So I need to go back. I mean, we update our models all the time. However, this is very important. I want to caution everybody. The models that you see, ladies and gentlemen, are context related. شو يعني? From my experience, you cannot take a model that was developed for the United States and apply it مثلا in the kingdom. مظبوط؟ Okay, so it's the same context of the parcel. If you want your pulsar to be drawn based on a new area that you know, it is better, from our experience, to train it on an existing area that looks like the one that you want to go to, and then at this point, it will generate the outline for it, okay? That's very important. So, can you start with an existing model, do further training, and in such a way that this model can be used to do drawing on this area? Yes. But again, كلمة كتير مهمة قلتها. For you guys that speak Arabic, everybody speaks Arabic here, I have a feeling. Okay, so if I switch, please forgive me. When you do the training, you need to take 20% of the area that you're going after. شو يعني? If you want to work on this area in here, look at, divide it into 20% of things that are representative. شو يعني؟ مثلا نعرف مثلا in Riyadh there are various areas. There's development areas, brand new areas that have building, brand new old areas that are totally different, right? So you cannot just train مثلا on the old area of Riyadh, or the old Riyadh, and try to imply parcels in the new development area where everything is square and beautiful. You have to do both simultaneously. Okay? And that's what you do. So, is it possible? Sure. Again, caution. It is a process, ladies and gentlemen. Ahmed here did a beautiful job showing I push a button, magic, unicorns, rainbow, and everything. Don't misunderstand me. Look at him. He's gorgeous, right? But I'm ugly. ليش؟ I'm ugly ليش؟ لأنه أنا متعذبت بهالأشياء. And this is because I pulled my hair working on this. Okay? So, I caution you, it's a process. It's a process. بتعلم, you label, you do, you try it out. But what we give you, هيدا الحلو what we do, when he went through it very quickly because he's short on time, he shows you the curves. تبعتوا لهم هدول الكيرفز هدول كتير مهمين الكيرفز to compare how well I'm doing compared to the other one. Okay, so though it is very good, we made it very easy. It's a process, ladies and gentlemen. Okay, وكله ما تنسوا this is supervised mode of learning. شو يعني؟ يعني البني آدم عم بيعلم هالمكنه الاوجو المجدوبه، باردون على كلمه مكنه، اوكي؟ عم بيعلمها لهالمكنه كيف تتعمل. شو بتعلمها؟ بتطلع. اوكي، عشان هيك drawing what you want to draw. اوكي؟ Did that help؟
مش عارف بس السؤال يفهم غلط
لا ما في. طب شو بده يرسم؟ شو بده يرسم يا رجل؟ سوري.
بشكل معين للداتا في الرسم ده بناء على بعض المعايير مثلا، فهو بيروح مثلا في خطوط، هو مش مجرد بيعمل ديتكتنج للمبنى، هو بيعمل ديتكتنج للاسوار نفسها بناء على بارامترز معينه. ايوه هو كلام ايوه كلام سليم، بس هو الدرونج هنا ايوه، بس هي بس فكره الدرونج اللي هو كان انت
سؤال فني. شو الانبوت اللي عم تعطيه؟
لا مش انا اللي بعمله، انا شفت حاجه زي كده فبسال هل اسري فعلا عندها حاجه زي كده ولا
لا لا هيدي
هو صدقني هو الدرون هو اكستراكتنج، بس هو عمل شويه بعد الاكستراكتنج. انت ما انتش شايف باك اند ولا عمل لك اللي هو يرسم زي الشات جي بي تي كده لما بتكتب له اكنك بيطلع لك ريزلت اكن واحد بيكتب قدامك.
انتبه. بعدين مش كل شيء بتشوف على الانترنت مزبوط يا رجل.
يعني ككونسبت انا مش مقتنع بيه صراحه، ان هو عمليه الرسم هي عمليه اكستراكتنج وبعدين هو بيعمل زي ديلي وبعدين يبين لك ان هو بيرسم. ده
وارد، مش هقول لك لا، ده صحيح.
منصور متفق معايا ولا لا؟
هلا فيك تحول مثل ما بتعرف بوليجون لا يعني دروينج، يعني تنرسم يعني هيك على البطيء يعني اذا بدك. اذا هيدا اللي بدك اياه هيدي هينه، انه يعني انه هو عمل
تخيل
هو ديتكت البوليجون بس اخذ وقته يرسم السطر.
هو ده الفيجواليزيشن اللي ده الخداع
حتى
البصري
يفرجيك انه عم بيرسم، انه هو الذكي عم بيرسم. بس شو عملوا هن؟ بطئوها يعني.
مزبوط انا
بدل يكون 16 فريم بير سكند عملوا 1 فريم بير سكند.
صحيح.
اوكي،
خداع بصري يا منصور. شكرا منصور، خداع بصري. في اي سؤال اني كوتشن؟ شكرا لكم يعني. اتفضل. شكرا.